Jupiter may be the biggest planet in the solar system, but its days are numbered. Into oblivion. How many nukes would you need to do the job? What obstacles would these rocket-bound bombs encounter on the way? And would one nuclear explosion ignite the entire planet? This is What If, and here's what would happen if we nuked Jupiter. Okay, quick brain fact. Did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, your brain treats it like active learning, decoding and making sense of new ideas just like it does when you solve a puzzle. So, watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA's spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling, now being brought to streaming for the first time. So, if you ever finish one of these streams and still want more, well, you don't have to wait. You can jump straight into Popular Science and keep that curiosity going. It's there 24/7, ready whenever your brain wants its next aha moment. Nuclear weapons are so powerful that even the low-yield versions, like those dropped on Japan by the United States in World War II, have the explosive equivalent of 15 to 20 kilotons of dynamite each. What makes them so volatile is that they harness the intense energy-releasing power of nuclear fission or fusion. These are the same processes that happen in our very own sun. So be careful when moving these things out to Jupiter. One false move and you could be incinerated by a fireball as hot as the center of the sun. In order to blow Jupiter to bits, one single bomb wouldn't necessarily be up for the task. Good thing for this scenario that there are a lot of nuclear weapons on Earth. Maybe the safest plan would be getting them all off our planet anyway. Given the top-secret nature of military activities, it's hard to know the exact number, but estimates put the global arsenal at about 12,700, with the United States and Russia battling for top spot with 5,500 to 6,000 weapons each. Okay, there's no use in delaying. Let's get these rockets off Earth as fast as possible. The distance between Earth and Jupiter fluctuates from about 590 million to 970 million kilometers. In the past, missions like the Galileo space probe took nearly 5 years to make the journey to the gas giant. But our rockets wouldn't take this long. Galileo had to be slow enough to enter Jupiter's orbit. We just need to hit the planet head-on, so you'd only be looking at about 550 to 650 days to get the job done. You shouldn't be too reckless and speedy, though. You don't want to nuke something else by accident. Now, bypassing the Moon and Mars would be easy enough, but getting safely through the asteroid belt would be like navigating a minefield. There are millions of asteroids riddled between Mars and Jupiter, and while the average distance between them is a not-so-worrisome 966,000 kilometers, sometimes it can still get a little cramped in there. And Jupiter is partly to blame for this. The planet's massive gravitational influence causes many of these to group into clusters known as families. Carelessly navigate through one, like the Flora family, and you'd better hope none of our rockets would collide with any of its 400 asteroids. For the best chance of success, you should aim to transport your rockets through the Kirkwood gaps. These are nearly asteroid-free regions in the belt, because you'd hate to see all of our planet's nukes detonate themselves in a blinding chain reaction before reaching our target. As the first of our bombs exploded on Jupiter, you'd see bright flashes back here on Earth. Just like when the Shoemaker-Levy 9 comet slammed into Jupiter in 1994. But that only released 5% as much energy as the Tsar Bomba, the largest bomb ever created. So, with thousands of our nuclear bombs, Jupiter's days would have to be numbered, right? Well, not exactly. Even though our nukes could produce an explosion hotter than the Sun, this wouldn't cause all the hydrogen on Jupiter to ignite. It just isn't dense enough to sustain nuclear fusion. And even if every bomb was detonated, Jupiter wouldn't blow up completely either. In order to do that, we'd need to unleash as much energy as the Sun releases over 160 years, all at once. And for that highly energetic result, about 1 billion nukes would be required. Somewhat more than the 12,700 in our arsenal. To build that many bombs, you'd need a combined mass of material that would almost be twice that of the largest moon in the solar system, Jupiter's Ganymede. No small feat, since it's bigger than Pluto and Mercury.
Do you see that? Well, obviously not, you're looking at me. But that's Jupiter! And guess what? Nobody knows exactly what it's made of. But today, we're gonna fix that, because I'm jumping straight in.
Would you like me to pull the information I have on Jupiter's composition?
No, not now, Rico. Okay, so there are some things we do know about Jupiter. For example, the fact that it has 5 layers. Rico seems to think I won't make it past the 3rd one, but I'm gonna prove that silly robot wrong. I mean, I have to, because once I get to that last layer, it's gonna make me rich, baby. Space rich. And all the while, I'll be filming some epic, never before seen footage for you guys. Nothing can go wrong. Ow. Okay, we're heading off to Jupiter in a bit. I just have to refuel first. Rico, was there no other moon to make a pit stop? Ganymede is like so freezing out here. It's like a minus 130 degrees.
Despite its sub-zero temperatures, Ganymede is an optimal landing choice, as it is the only moon in the solar system with its own magnetic field.
Fine, well Jupiter has the answer to my refueling problems forever, so long as I get to its mystery core.
It's true that we don't know for sure what Jupiter's core is made of, but we do know that Jupiter is the largest and oldest planet in our solar system. It has more than twice the mass of all the other planets combined. And with a radius of 70,000 kilometers, it's 11 times wider than Earth. This planet is also a gas giant made up of the leftovers from the formation of the Sun 4.5 billion years ago.
Oh, damn! Rico, Jupiter has a massive freaking pimple! Let's land there.
Warning, The Great Red Spot is a high-pressure anticyclone in Jupiter's atmosphere. Winds there reach speeds of 680 kilometers per hour.
Of all the places on Jupiter, the Great Red Spot is the last place you want to fly into. It's a storm that's been raging for at least 300 years. It's a lot bigger and a lot scarier than anything you've ever experienced on Earth.
I'll just approach it hurricane style and fly right down the center. It'll be fine. This is it. First person to ever fly into Jupiter's big red hole or whatever. Here we go.
Warning, temperature rising rapidly. Atmospheric temperature over 1,300 degrees Celsius.
Rico, what's going on?
System overheating. Cooling system.
Rico? Rico, you know I don't like pranks. Stop messing around with me, man.
This raging storm is so powerful, it creates sound waves that heat particles in the atmosphere and make this area 1,000 degrees hotter than the surrounding atmosphere. So, if you land here, you can count on, well, some discomfort.
Okay, I can fix this. Oh, no. Oh, gosh, okay. These winds are way too strong. You know, if I close my eyes, it kind of feels like a roller coaster. I'm having fun. This is fun for me.
Jupiter's clouds are mostly ammonia and water. Because the winds on Jupiter are so violent and flow in opposite directions, they shape the clouds into conveyor belts around the gas giant. Some of the clouds reach speeds of up to 500 kilometers per hour. Not that you can avoid them now, as you've already plummeted into the raging planet.
Okay, wow, it's so cold that the ammonia is freezing into ice and hitting me in the face. Cool. Ouch. Rico, please come back. If you come back, I promise I'll never be mean to you again. Huh? Oh, finally! Rico, you can't just take a siesta in the middle of the day, okay? We're not in Spain. We're in space. Now propel me to the second layer of the atmosphere. Idiot.
Propulsion commenced.
Oh, what is that smell? Rico, did you fart?
Negative.
Did I fart?
No one passed gas. At hotter temperatures, the ammonia in the clouds combines with the sulfide compounds to create ammonia hydrosulfide, which smells a lot like rotten eggs.
Oh, God, it smells really bad in here, Rico. Maybe alien life does exist on Jupiter, except they all died a long time ago. Or maybe somebody hotboxed Jupiter with a bunch of burning trash. Ugh.
No, it's just the ammonia hydrosulfide.
Oh, God, this sucks, Rico. Let's go to the next layer, quickly.
Depth reading. 200 kilometers below Jupiter's clouds. You are now in the outer interior. Atmospheric contents include hydrogen and helium.
Oh, chilling with some pretty standard stuff then. Hydrogen, helium, one cool as hell guy. It's just getting a little, hot.
Pressure reading, 3,039.75 bars. Temperature reading, 1,890 degrees Celsius.
It's so hot in here. I'd take the suit off, but then I'd die, so no thanks. Not dying like that again. I don't know how much pressure my camera can take because it's like the air, it's getting all weird and liquidy. This feels very tight in here.
Imagine 100,000 cars stacked on top of you from every direction. That's what it feels like as you approach Jupiter's interior. The pressure is so intense that even hydrogen atoms can't withstand it. Under that immense pressure, hydrogen atoms shed their electrons and form a charged, electrically conductive liquid. Think about what that can do to the atoms in a human body.
Think about it? Think about it? I'm living it, baby! And it hurts! Ow! Rico, quick, Bing, cures for lungs being crushed by unreasonable amounts of pressure on WebMD.
No cure available.
Oh, okay, search the Facebook comments.
Negative. If left untreated, you will experience inevitable death via liquidation.
Oh, God. Oh, I'm gonna be sick. Rico, open the space sick valve.
There is no spacesuit sick valve in this model.
What? What kind of crappy suit doesn't have a space sick valve? Ah! Oh, man. I feel really sick to my stomach.
Nausea is not a symptom of high pressure.
What?
Yeah, maybe I should have mentioned earlier that the charged liquid hydrogen paired with Jupiter's rapid rotation creates one heck of a magnetic field. It accelerates charged particles to such high energies that anyone who enters Jupiter's magnetosphere is exposed to toxic radiation immediately. Luckily, Chase's spacesuit is strong enough to delay the effects for a little while.
Ah, great. So it's a race to what'll kill me first? The pressure, the radiation, or those droning voiceovers? Luckily, I've managed to make a few upgrades to my suit along the way, so I should be able to last about another 15 more hours. Rico, let's get going. What if guy, feel free to stay behind.
Warning, you are entering uncharted territory.
Wow, don't be mad, Rico, just because you thought I'd be dead at this point. I can't see anything. Rico, activate the augmented sensory system.
Activating stage 1 of ASS.
And this is why I decided to come here. This is metallic hydrogen. If I collect enough of this stuff, I'll be richer than Jeff Bezos.
You can collect enough metallic hydrogen to power your spaceship for 2 billion light years and repay all your burger debt. Leaving now would provide just enough suit resources to make it out alive. This could be your first successful mission.
Yeah, I mean, we could leave, but we're so close to the core. I'd be the first YouTuber ever. Let's just pop in for a quick check.
Unintelligent idea detected.
Rico, I'm so bored. Are we there yet?
You've been sinking for 4 hours. You have 8 more to go.
Oh, God, I'm so bad with time management.
Also, you have less than 9 hours of suit protection left.
Well, I guess this is a good time to tell you guys to go like and subscribe. I'm trying to become the first YouTuber to explore all of space, so, help your boy out. If you like and subscribe, we can go do more of these cool videos.
Approaching the planet's core. 5 minutes of suit protection remaining.
Okay, gotta move fast. What do we got down here? Some sort of crazy alien life or super weapon, maybe like a Stargazer or some crazy super material.
Detecting ice, rock, and metal.
Okay, that sounds like stuff you could find on Earth. Maybe I need a second opinion.
Jupiter's core was made over 4.5 billion years ago during the creation of our solar system. Due to the extreme pressure and temperature, the core is not a kind of hard surface you might walk on. It's pretty liquid-like.
30 seconds of suit protection remaining.
You know what? I don't want to hear any of this negativity, Rico. Just get me out of here, okay? Activate the specialized upflow cyclone kit.
Suck not available. Suit protection failing.
The suck sucks. And why is it so hard to breathe and so hot all of a sudden?
Your suit protection is now depleted. You are now experiencing a pressure of 43,090,032 bars and a temperature of 29,095 degrees Celsius. The intense conditions are quickly crushing your lungs.
You get crushed along with me, Rico. Did you know that Jupiter has 95 moons? And some of them are big, like planet-sized big. I'm gonna populate these big moons of Jupiter and see which one isn't gonna kill me. Alright, so I'm starting on Callisto. It's the furthest moon from Jupiter, which means it also has the worst view. Ugh. Oh, no, that's nothing.
Callisto orbit detected 1,883,000 kilometers from Jupiter.
Okay, so if you haven't heard about Callisto, here's some facts. 1, it's a moon. 2, it's pretty big. 3, it's only slightly smaller than Mercury, which is a full planet. So I call this rock almost planet-sized. Now walking on Callisto is fun because it's like walking on Earth's moon. The gravity here is so low, it's almost like I'm floating. All right, let's take a look around, I guess. Terrain looks real bumpy.
Billions of years of impact from asteroids and comets has made Callisto's surface the most heavily cratered in the solar system.
Oh, well look at this! A crater perfectly sized for a pool, and what's a home without a pool, right Rico?
The temperature on Callisto is minus 140 degrees Celsius. Water will freeze immediately.
Okay, an ice rink then. This one will be an ice rink. We'll heat this one to be a pool then. And, And this one will be an ice plunge. Very Scandinavian. I'm getting to work. Oh, welcome to the crib. I know that I said that this was gonna be the worst moon, but, it's actually looking pretty nice. You see these pools over here? The only reason they stay intact is because there's almost like no geological activity on Callisto. That's right, no volcanoes, no earthquakes. It's kind of perfect here. Nothing can kill me. Foreshadowing. Even though the view sucks, the distance from Jupiter means that there's way less radiation that'll impact my bath time.
Correct. Callisto is located mostly outside of Jupiter's intense radiation belts. That means that the radiation exposure is actually reduced.
Hear that? I don't have to worry about turning into some freakish ugly guy.
Correct. The mutation has already occurred.
Rico, what the hell?
What if Guy programmed me to say that?
Ugh, damn. Even when he's not in the video, Peter leaves a stink on everything. Alright, well, let me show you around. I just used this nice rock as the base and basically drilled out the insides, and then I took some rocks from over there and over there to finish it up. I'm hoping for a granite entryway, which is tough because I have no idea if granite exists on this planet, moon, whatever. Then I insulated it with some nice thick layers of polyurethane to keep it nice and toasty inside. Now I couldn't get the gas fireplace in, so we're gonna need a little bit more insulation because it's not gonna... Well, at least this gives me extra building material. Sometimes life gives you lemons, and other times life gives you asteroids. I would have preferred lemons, but you know what they say? Suck it, Chase, you don't get any lemonade. Fine, fine.
Current location, Ganymede, the largest moon in the solar system.
Living on the biggest moon? Pretty cool. Very chic. But this looks bleak. AF. Rico, how well could Ganymede promote life whatever, you know? Do your robot thing, Rico.
Ganymede generates its own magnetic field, which protects the moon from cosmic radiation. This is a very positive indication for sustaining life.
Nice. No mutating for me here either.
You could not mutate into a worse-looking guy.
Dude, I'm gonna slap you, Rico.
Another pre-programmed response.
Yeah. Whatever, just keep talking about Ganymede.
Ganymede also contains an underground saltwater ocean, estimated to be 100 kilometers deep. That is 10 times the depth of the Earth's ocean.
Oh, okay. Oh, this is giving me some ideas. Yes, okay. I'll drill through Ganymede's 150 kilometer thick ice crust and tap that ocean water. I'll set up my own plumbing system. This is perfect. Oh yes. I'll build a shelter inside this crater. You know, that has a pretty nice hippie commune vibe. Right? And sure, it is minus 180 degrees Celsius, but I'm pretty sure once this place gets populated with all those alien hippies, we'll warm each other up just fine. Okay, well, I'm still drilling, but that's only because it's such a thick ice crust and deep. But, you know, I'm determined to have a toilet that can flush. All this manual labor. It's making it so steamy in my spacesuit.
Current temperature reading at minus 126.3
Rico,
degrees Celsius.
If I could just take off my helmet and get a little bit of this Ganymede ice on my forehead, that would cool me down so quick. What's the possibility of that?
While Ganymede's icy surface does generate a thin atmosphere of nitrogen and oxygen,
Oxygen in the atmosphere? Nice.
not enough to sustain your air supply.
What? You should have said that way faster! Where'd I put my helmet?
Okay, I admit that one was my fault. Mostly Rico's, but some blame goes to me. Alright, what is this, Europa? I thought Italy was supposed to have a lot more pizza and people.
Europa is the fourth largest of Jupiter's 95 moons.
Right. The moon thing, we're still doing that. Europa, whatever. You know, I'm actually feeling pretty good about this one.
Your intuition is correct. Europa has the highest chance of fostering life.
But it's all ice. I mean, last I checked, life was a little bit happier in nicer, warmer climates. You know, somewhere with like a beach and like a 24/7 pina colada service.
Negative. Europa has signs of water. Scientists discovered that this moon disrupts Jupiter's magnetosphere due to the presence of an electrically conductive fluid, most likely a large ocean of salt water.
Oh, okay, nice. Well, but this time I am not drilling down for plumbing. I'd rather live in filth.
Europa's surface is blasted with radiation. Enough time in here would mutate
you into a worse looking guy. Yeah, I got it, Rico. Thank you very much. God, I really gotta put a password on your code base. All right, well, I guess I'll drill if I have to. Okay, you guys, this might be the sickest habitat yet! Look at this. So I drilled through the ice shell, which was like 22 kilometers thick, which sounds like a lot, but it really wasn't compared to last time. We got some reinforced glass to sustain all the pressure from that water. Oh, and get this, Europa has this crazy elliptical orbit, which causes all these tidal forces, which could lead to volcanic activity on the seafloor. I know what you're thinking. Chase, volcanic activity right under your house? Won't your house explode? What about the property value? For one, the ocean is like 150 kilometers deep. We're fine. Chill out. Second, that hydrothermal activity could supply nutrients to the ocean floor, which could allow us to watch alien evolution right from my bachelor pad. And thirdly, I made this glass super reinforced. I watched a YouTube tutorial, so it's gonna probably withstand basically anything. So we are going to be utterly and totally fine. Rico, take me somewhere safe!
Locating a geologically stable zone.
It's just.
Io is the most volcanically active body in the solar system.
Oh, really? You don't say! Thank you, Rico!
Some eruptions are hundreds of kilometers high.
Yeah, thanks! Tell me something I don't know.
Okay, Taylor Swift's Eras Tour had a total of 149 shows.
No, about Io, you idiot! Wait, were any of them on Io? I still wanted to get tickets. I love that song where she goes something about her boyfriend, or whatever.
Io is forced into an elliptical orbit by the gravitational pulls of Jupiter, Europa, and Ganymede. Its proximity to Jupiter and this irregularity cause extremely unstable geological activity.
Ah, dang. Okay, well, sounds like it's gonna be pretty difficult to, live here, but Chase finds a way. Chase always finds a way. Ah! Whew. Okay, that was stressful. Let's try and stay away from the volcanoes, okay, Rico?
New volcanoes erupt around Io due to the constant heating of the moon's interior. Volcanic activity could begin at any moment.
Okay, well, great. I guess we'll just have to gamble. Oh, man, I just escaped like 100 spewing volcanoes. Why is it so cold here all of a sudden?
Io's atmosphere is too thin to trap any heat, so geologically stable zones of the moon reach temperatures as low as minus 130 degrees Celsius.
Well, that's about 150 degrees colder than what I would prefer. Oh, I know. We'll use the heat from this lava lake to heat up the exterior of my habitat. Oh, and I'll have a big underground bunker to shield me from any of the explosions. Okay. This is gonna be good. I'll see you in 1 week. Hey guys, so I just started tunneling down to get my bunker. It's tough going, but it's gonna be worth it. Rico? What's going on?
Geological activity.
Okay. It doesn't sound super.
Something incredibly strange is happening. A mysterious gravitational disturbance is altering our solar system. Jupiter is now on a crash course with the Sun. What happens when one gas giant collides with an even more gigantic one? How would Jupiter journey to the center of the solar system? Would the Sun become even bigger and more powerful? And how might this be a life-threatening situation for us here on Earth? This is What If, and here's what would happen if the Sun swallowed Jupiter. Okay, before watching the greatest collision in our solar system's history, it'd be good to explore a couple of the ways this event could unfold in the first place. In order for Jupiter to crash into the Sun, something truly extraordinary would need to happen. Its orbit would need to be drastically altered by a gravitational disturbance. And not just any disturbance, an absolutely massive one. The most likely culprits would be a rogue star or a black hole passing dangerously close to our solar system. And these objects would have to be really huge. At the very least, they'd need to be a couple times more massive than our Sun. As they drift through interstellar space, they'd eventually interact with Jupiter's own gravitational field. And considering that Jupiter is about 318 times more massive than Earth, its gravitational field is an expansive one. And whether this rogue star or black hole tugs it in one direction or transfers a bunch of kinetic energy, it would make Jupiter's orbit increasingly eccentric. But there's a pretty big catch here, though. Somehow, those gigantic rogue objects would have to pass by at the exact right moment. A moment where they would only impact Jupiter. Otherwise, it wouldn't be the only planet in our neighborhood careening out of orbit and toward an imminent heat death. After a few billion years of orbiting the Sun at an average distance of 778 million kilometers, Jupiter would begin its death dive toward our star. But this wouldn't happen overnight. It could take years, decades, maybe even centuries. The gas giant would need to travel this incredibly vast distance, accelerating faster and faster under the immense pull of the Sun's gravity. This process is known as spiraling orbital decay, and it would result in Jupiter orbiting in tighter and tighter spirals until, well, it reaches oblivion. The next phase of this planetary destruction would occur when Jupiter would be close enough to be torn apart. This is known as the Roche limit, and for a body as big as Jupiter, it would begin when it's just under 900,000 kilometers from the Sun. At a distance this close, the planet would become tidally locked, just like Mercury is. This means that it would only make one full rotation on its axis for every full rotation around the star. But for that to occur before the planet starts to disintegrate, its rotation speeds would also need to undergo significant changes. Currently, Jupiter makes one full turn every 10 hours. But to become truly tidally locked at this distance, it would need to more than double its rotation speed. If this were to happen, only one side of Jupiter would ever fully face the Sun. And each of the two sides would experience varying levels of gravitational pull, with the day side or near side getting stretched out more and more. Jupiter would no longer resemble a gigantic gaseous sphere. Instead, it would have a more oblong, elliptical shape. You can almost imagine Jupiter going through the process of getting spaghettified, like what happens when an object crosses over the event horizon of a black hole. Though this would be slightly less extreme. But that doesn't mean it's not the end of days for our biggest neighbor. Its atmosphere would be getting stripped away, forming a glowing ring of dust and gas around the Sun. This is called an accretion disk. And this is where Jupiter's existential plunge would get really interesting. Both the planet and the Sun are mostly made up of hydrogen and helium. So as Jupiter gets absorbed, would the Sun get bigger and more powerful? Well, considering that our planet is already warming at a dangerous pace, this could trigger some alarm bells for you. But don't worry too much. This collision isn't about to change much in terms of the Sun's energy output. As big as Jupiter is, it's only about 0.1% the mass of the Sun, so we're not talking about a hugely noticeable difference. For a short amount of time, the Sun would be a bit brighter as it converts all of Jupiter's energy. This would be the first effect that this whole scenario would have back here on Earth. You'd be treated to a little extra sunlight during the day, and the night sky would be a bit brighter as you watch Jupiter's final days before it vanishes into the sun. The biggest effect would come from the gigantic gravitational hole that Jupiter would be leaving in our solar system. For billions of years, it acted as a so-called cosmic vacuum cleaner by attracting comets and asteroids of all shapes and sizes. Without its presence, Earth would find itself exposed to dangers in entirely new ways. The chances of impacts from large objects known as planet killers would become higher. And that would be one of the greatest existential risks for all life forms on our planet. 11 times wider than Earth. Over 300 times more massive. And 1,000,000 times more terrifying. Jupiter looks like a beautiful ball of swirling clouds, but on the inside, it's a gaseous hell. What if things took a different turn for the king of the solar system? What if Jupiter wasn't a gas giant at all? What if instead it was a rock giant? What would its surface be like? What could make this world habitable? And what would happen if you tried to walk on it? This is What If, and here's what would happen if Jupiter was a rocky planet. Jupiter is old, like 4.5 billion years old. It started as a swirling disk of gas and dust that formed into a pretty big planetary core. With time, Jupiter's core grew, attracting more and more rock, ice, and metal. But Jupiter wasn't going to become a rocky planet. Now, it had an enormous appetite for gas. Yeah, Jupiter's powerful gravitational pull drew in massive amounts of hydrogen and helium that shaped it into the majestic gas giant we see today. But what if things went differently? You know, what if? What if, instead of gas, Jupiter kept pulling in more rocky materials until it became the most massive terrestrial world in the solar system? Would that be the end for everything in our planetary neighborhood? For this Jupiter apocalypse, we'll keep Jupiter's size just as it is today, only now, all rock, no gas. Jupiter would become unimaginably massive. This world would be 4 times heavier than its gas giant form, and keep in mind, the gas giant Jupiter is already about twice as massive as all the other planets in the solar system combined. And with this enormous mass would come unimaginably strong gravity. Rocky Jupiter's gravitational pull would now be 4 times more powerful than it was before. And that's about 10 times stronger than the gravity you and I live with here on Earth. Yeah, you wouldn't be able to walk on this rocky Jupiter. Your body would experience a gravitational pull so extreme that it would break your bones. Your heart would beat out of your chest, working so hard to pump your blood, and as your blood pooled in your lower body, you'd feel dizzy and lightheaded. Well, you may not want to walk on this Jupiter anyway. The rocky king of the solar system would now attract even more moons and asteroids, and some of them would be on a collision course with the rocky giant. But what would its surface be like anyway? Well, apart from the constant asteroid collisions, it could be a pretty nice place to visit. If you could walk there, of course. Rocky Jupiter would still lie outside the solar system's habitable zone, but this doesn't mean it would be a frigid world. Jupiter is gigantic, and rocky Jupiter could retain a lot of internal heat from when it formed, so even though it's much further from the sun than Earth, rocky Jupiter could have surface temperatures similar to our planet. It might even have hot oceans. Terrestrial Jupiter's gravity might cause the planet to have a very thick atmosphere, and worlds with thick atmospheres have, high atmospheric pressure. That means that the boiling point of water on this rocky giant would be higher than it is on Earth, and the oceans could be as hot as 200 degrees Celsius and still remain liquid. Yeah, we're not going swimming there. Even if you could somehow walk on this world, you wouldn't want to breathe on it. Gas giant Jupiter's atmosphere is mostly hydrogen and helium, so if the rocky Jupiter's atmosphere was also made of hydrogen and helium, it wouldn't be breathable. Then there would be the lightning storms. Yeah, Jupiter already has massive storms in its clouds, and rocky Jupiter would be no different. If this planet also had active volcanoes spewing ash and lava, well, that would make the lightning storms even more intense. Volcanoes could be good news for the rocky world, though. The gases they release might change the atmosphere of rocky Jupiter and make it habitable. And if not for you, maybe for some other life forms. And those other life forms could be terrifying. They might be bigger and stronger than dinosaurs, just to withstand Jupiter's enormous gravity. Or they could be tiny microbes living under rocky Jupiter's surface, but obviously that's a lot less exciting. The thing is, Jupiter's increased gravity would push our planet out of its stable orbit, and that would dramatically change our climate. Earth could be pushed closer to the sun, turning this place into a hot, hellish world. Or we could be driven further from the sun and freeze over. Either way, it's bad news for you. It's time for one of the biggest battles our solar system has ever seen. In this corner, a gas giant and heavyweight Jupiter. And in this corner, an infinitely small but truly terrifying black hole. What would happen to these rivals as they hurtled toward each other? Why would this event cause Earth to be bombarded by asteroids? And would it be game over for our solar system? This is What If, and here's what would happen if Jupiter collided with a black hole. Okay, before the fight, let's take a quick look at exactly what each contender is up against. Starting with our solar system's favorite. Jupiter is the 5th planet from the Sun, located about 740 million kilometers from it. This gas giant is the largest planet too. It's about 318 times more massive than Earth and twice as massive as all the other planets in our neighborhood combined. But looks can be deceiving. Compared to its opponent, the heavyweight Jupiter isn't all that heavy. Stellar black holes are a lot smaller than our gas giant, but they sure can pack a punch. The thing about black holes is that they are dense, incredibly dense. All of their matter is contained within an infinitely small point known as a singularity. And inside this tiny region, all concepts of time and space fall apart. And like any object with mass, black holes have gravity. A lot of gravity. Most black holes are remnants of massive stars. They're called stellar black holes, and they range from 3 to 10 solar masses. But because they're so dense, if a black hole with 10 times the mass of our Sun appeared in our solar system, it would only be 60 kilometers across. So, would our gas giant Jupiter stand a chance to defeat its tiny but immensely powerful contender? Or would it just be another object lost inside the black hole's point of no return? Everything in the universe is moving through space at breakneck speed, and naturally, that includes the Sun and the rest of our solar system. We're whizzing across the cosmos at about 720,000 kilometers an hour. And in this galactic dance, another star may come close enough to us to influence the outer regions of our solar system. Or worse, we might run into one of the nearly 1 billion black holes rampaging around the Milky Way galaxy. Of course, the chances of this happening are slim. The closest star in our neighborhood is over 4 light years away, and that's far. Scientists think that there's only a 1% chance that another star will ever come close enough to disrupt the edges of our solar system. The chances of a rogue star coming close enough to mess with Jupiter are even lower. But it could happen. At first, as this stealthy force of destruction swung toward us, the black hole would disrupt the Oort cloud. This area surrounds our solar system like a giant spherical shell, and it's filled with icy objects. But these mountain-sized ice cubes would be no match for a black hole. As they were pulled along for the ride with this small but massive monstrosity, this would be the first sign that an epic collision with Jupiter was unavoidable. The gravitational intruder would continue through the next region, the Kuiper Belt, and it would wreak havoc along the way. Many of the icy objects here, including the dwarf planet Pluto, would be ejected from their orbits. Things would suddenly get more serious for Earth, as many of these objects would now be on a deadly collision course with us. As it passed Neptune, Uranus, and Saturn, the black hole would tear away their gases. These gases would form an accretion disk of superheated gas and dust around the gravitational intruder. And if the black hole came too close to any of these planets, they could also be at risk of being ejected from their orbits. Then, the black hole would finally bear down on Jupiter. And right away, the gas giant would experience a similar attack on its atmosphere. The black hole would pull away hydrogen and helium gases like yarn from a yarn ball. Eventually, the entire planet would be pulled toward the black hole. It would be an unfair fight from the get-go. Jupiter wouldn't even be able to get a punch in, and if all this isn't violent enough, just wait. As this dense and hungry monster chowed down on Jupiter's abundance of gas, it would also release an explosive wave of UV and X-rays in all directions. Yeah, it would be like one big supermassive burp packed with deadly radiation. This radiation would hurtle toward us on Earth. In less than an hour, lethal amounts of radioactive material would rain down on us. But on the bright side, you'd finally be able to see the black hole up in the sky. Whatever stability we enjoy in our solar system would be gone. The black hole would be swallowing up everything in sight, including our planet. Now, if we somehow managed to be spared the full brunt of the black hole's destructive forces, well, without Jupiter, our solar system would need to find a new gravitational balance. Yeah, Jupiter had a special place in our neighborhood. Its enormous gravity kept asteroids and comets from pummeling us and other inner planets of our neighborhood. It also helped Earth maintain its nearly circular orbit around the Sun. So even if we survived all the gravitational havoc from a rogue black hole, without Jupiter, this little space rock we call home wouldn't last long. Jupiter is a massive, terrifying planet, and despite being studied for centuries and even visited by 9 space probes in the last 50 years, the undisputed king of the solar system has managed to keep some things hidden from us. Until now. From planetary cannibalism to the giant spots you've never seen before, we're going to uncover all of Jupiter's dark secrets. Okay, you've most definitely heard of Jupiter's Great Red Spot, the gigantic storm that's been raging for hundreds of years. Yeah, it's freakishly big, like wider than Earth kind of big. If Earth had a storm like that rampaging on its surface, well, there would be no more Earth as you know it. But what you might not have heard of is that there's a new massive storm in town. Yeah, this one's called the Great Cold Spot. And this one is weird. For one, it's almost as large as the Great Red Spot. It's also the coldest place in Jupiter's clouds. About 200 degrees Celsius cooler than its surroundings, which is how it got its name. So, how did we miss this gargantuan hurricane? Well, I think we've just been mesmerized by the swirling clouds of the gas giant and didn't look closely enough at Jupiter's poles. And that's exactly where the Great Cold Spot has been hiding. But that's just what I think. Scientists have a cooler explanation. The real reason why it's not easy to observe the Great Cold Spot is because it's hiding behind Jupiter's powerful auroras. Yeah, the same kind of phenomenon as Earth's northern lights, only many, many times more powerful. On top of that, unlike the Great Red Spot, which is not eager to change much, the Great Cold Spot is volatile. It's constantly growing bigger and smaller and bigger, changing its shape in a matter of weeks, even days. Try to keep up with that. And scientists still don't fully understand how it formed. I mean, we know that the Great Red Spot is powered by Jupiter's swirling gases, but the Great Cold Spot could be fueled by auroras. And Jupiter's auroras would be a remarkable sight to see. They aren't exactly like the ones on Earth. We get our space light shows thanks to the sun's solar wind, but Jupiter's auroras don't rely much on the sun. They appear thanks to the charged particles inside Jupiter's unimaginably huge magnetosphere. Most of these particles come from Jupiter's volcanic moon, Io. If the Great Cold Spot is really formed by auroras, then it might be thousands of years old. Way older than the Great Red Spot. And it's not the only mysterious spot lurking in Jupiter's deadly atmosphere. Among the gas giant's beautiful swirling gases, there lies a dark vortex with an intriguing name: the Great Abyss. This is one of the most baffling features scientists discovered on Jupiter. And let me remind you, we've sent 9 probes to this giant. From Pioneer 10, the first spacecraft to fly by Jupiter in 1973, to Juno, the most recent space probe to do an in-depth study of the planet. It took Juno 20 passes to finally notice and capture this dark center of the Great Abyss. And yet, scientists don't know exactly what this pitch black hole is or how it formed. I would call it Jupiter's Great Black Hole, but I guess that name would be a little bit confusing. Besides, the Great Abyss isn't anything like a black hole. It's the very dark center of a vortex. It might run deep, but at least it wouldn't suck you in like a black hole would. Likely not. Jupiter's atmosphere is horrifying. The gas giant is mainly made of hydrogen and helium, but its clouds are a lot more dangerous than that. On the top, it's all ammonia ice, and as soon as you dive deeper under the colorful patterns, you'd likely encounter ammonium hydrosulfide crystals. And at the very deep depth of the gas giant, there's water ice and vapor. Yeah, that's right. Jupiter doesn't have a solid surface. And it's freaky. Jupiter is basically a frigid, cold cloud floating in space, with a large hydrogen ocean at its center. Yet it's the biggest planet in the solar system, more massive than all other planets combined. Then there are winds. Jupiter's winds are ridiculously scary. They're strong enough to blow more than 3 Earths worth of material around the planet. At the equator, they go as fast as 540 kilometers per second. And deep into Jupiter's atmosphere, these winds might be blowing Jupiter's magnetic field off. Jupiter's magnetosphere is gigantic. It's 21 times the diameter of Jupiter itself. No other planet in the solar system can boast a stronger magnetosphere than Jupiter's. And as if that's not enough, this gas giant has not 2, but 3 magnetic poles. One at the North Pole, another one at the South Pole, and the third one lies near Jupiter's equator. It was just recently discovered by Juno and was dubbed the Great Blue Spot. I mean, is it just me, or could Jupiter's spot names use a little variation? Scientists have noticed how the gas giant's magnetic field changes over time, and now they think the intense winds might be causing these changes. Well, that's just mind-blowing. But you know what's even more stunning than that? It turns out Jupiter is a planetary cannibal. In the early days of our solar system, the gas giant was one of the first planets to form. It really explains why it's so gigantic, but despite being so gassy, Jupiter has a lot of heavy elements inside it. And thanks to Juno, we now know that this monstrous planet has about 30 Earths worth of heavy elements in it. All because Jupiter is literally gobbling up other planets. Okay, they're not exactly planets, more like planetesimals. These are clumps of dust and rock that can be hundreds of kilometers across. If Jupiter hadn't eaten them for breakfast, well, these clumps could have become a new planet, like Mars or Earth. Just imagine what having another rocky planet in the solar system would be like. Well, sure, it could have pushed Earth out of the habitable zone. Or this new planet could have crashed into Earth, leaving us without any chance to thrive here. It's all over for Uranus. The ice giant is locked into a collision course with the king of all planets in our solar system, Jupiter. What would happen as the two planets made their epic approach? Would Uranus get pulled apart into bits and pieces? Or could this ice giant somehow deal a mortal blow to its gigantic opponent? This is What If, and here's what would happen if Jupiter and Uranus collided. Okay, let's get to know our two planetary prize fighters a little better. You know, before they both potentially get blown into oblivion. First, Jupiter, the largest planet in the solar system. Put all the other planets together and it's still twice as massive, but this monstrosity has no solid surface. It's nearly all gas, mostly made out of hydrogen and helium. In the other corner of the ring is Uranus. Even though it's 3 times smaller and 20 times less massive than Jupiter, it's the third largest planet in the solar system, so don't let the size difference fool you. Underneath Uranus's hydrogen and helium atmosphere, there's an abundance of water ice. That's why Uranus isn't a gas giant like Jupiter. It's an ice giant, like its neighbor, Neptune. Of all the planets in the solar system, Uranus is unique. It rotates on its side, all thanks to an Earth-size object that slammed into it billions of years ago. So, could the most epic collision in the history of collisions end with Uranus getting knocked right side up? You likely don't track Uranus's whereabouts in the night sky, but if you did, you'd be in for the realization that the icy planet has somehow slipped out of its usual orbit, commencing countdown to collision. On its way toward Jupiter, Uranus would first need to survive a close encounter with the gas giant next door, Saturn. With all its colorful rings and many moons, Saturn is twice as large as the stinky blue planet. But the two planets have very similar gravitational pulls, so as they just barely brush past one another, well, Uranus could end up sweeping up a moon or two to add to its current collection of 27. Uranus would now be barreling down onto its opponent. The closer it gets, the clearer the picture would become of just how incredibly enormous that opponent is. Jupiter is over 20 times as massive as Uranus, and even though it doesn't technically have a surface, its surface gravity is more than twice as strong. Maybe Uranus was barking up the wrong planetary tree. Except it's too late to turn back now. Besides, you've got front row seats to this epic fight. It wouldn't be smooth sailing right up into Jupiter's atmosphere. First, Uranus would have to elbow its way through some of Jupiter's 80 moons. The first of these would be Pasiphae. There wouldn't be too much to worry about here. Pasiphae is very small. It's more than 60 times smaller than our moon. Uranus would pass right by it and the remaining minefield of Jupiter's moons completely unscathed. Okay, now the planetary heavyweights would be getting close. But how this collision would unfold would all depend on Uranus's angle of impact. If it somehow managed to slip into Jupiter's orbit, then the two would be on course for a head-on collision. In this event, the atmospheres of both planets would compress as they came into contact. This would result in both of their temperatures rapidly increasing. And then, boom! No, I'm just kidding. With no oxygen on either planet, they wouldn't ignite in fiery explosions. But if you're only in it for the spectacle, well, don't worry. The collision would still be very violent. The two planets would make full-body contact, combining their mass along the way, like a Uranus or maybe a Jupiter. One thing that wouldn't happen, though, is Jupiter turning into a star. In order to become a brown dwarf, it would need to weigh 13 times more than it does now, or 85 times more if it wanted to become a low-mass star. Sadly, adding Uranus under its belt would only increase Jupiter's mass by a fraction. Now, more realistically, Uranus would hit Jupiter from the side. This collision would also begin with the two atmospheres compressing, except instead of merging into one, they'd both remain somewhat intact but have a lot of their gases thrown off into space. So, after this epic encounter, we'd still be left with 8 planets in the solar system. Though these two would certainly look a little different. Jupiter would look like a thinner version of its formerly huge, gassy self. And Uranus could end up being not much more than a solid rocky core covered in water and ammonia. If things unfolded like this, then that could leave Saturn to take over the throne of largest planet in the solar system. One minute, you're setting up a new space station orbiting Jupiter, and the next, you're plunging right into the middle of a giant red cyclone of death. What would the storm of all storms look like on the inside? How would it compare to storms back on Earth? And which one of Jupiter's tremendous forces would strike the lethal blow? This is What If, and here's what would happen if you fell into Jupiter's Great Red Spot. The Great Red Spot is the biggest storm in the solar system. At about 16,300 kilometers wide, well, it's large enough to swallow the Earth whole. It's a lot like a hurricane, only instead of lasting a few weeks, this giant storm has been rampaging for at least 300 years. And instead of forming from warm air, this monstrosity gets its energy from the dense atmosphere of Jupiter. Fueled by an abundance of the planet's hydrogen and helium, the Great Red Spot reaches 500 kilometers into its atmosphere. Oops, you should have built your space station a little farther away. Okay, well first, how on Earth would you even get to Jupiter? Well, if you traveled light and followed the route of the Voyager spacecraft, you'd arrive on Jupiter in just under 600 days, but this journey wouldn't be as simple as just pointing yourself at what appears to be a very bright star in the night sky. Roaming the solar system in a spaceship is a little more complicated than that. You see, the Voyager never intended to land on Jupiter, only to pass it on the way to interstellar space. So if you followed Voyager's path, you'd whip right past your target. For this to work, you'd need to follow the lead of the Galileo spacecraft, launched in 1989. Just like Galileo, you'd swing by Venus and then back around Earth for a little gravity assist. This way, you'd have the right speed to park in Jupiter's orbit. Only the trip would now take you 6 years instead of 600 days. By the time you reached Jupiter's moon Europa, the planet would appear 22 times larger to you than a full moon did back on Earth. And you'd still need to get a little closer. Now you'd be mesmerized by the planet's swirls and stripes. These are colored red, brown, and white, thanks to the sunlight reflecting off massive clouds made of ammonia and ammonium sulfide. Finally, you'd feast your eyes on the Great Red Spot, a giant twirl of the atmosphere rotating counterclockwise. It looks a lot bigger than you could imagine. But before you even begin your descent into the Great Red Unknown, your life would already be in grave danger. Jupiter's powerful magnetic field would shower you with intense radiation. I mean, luckily, you'd be equipped with a highly advanced protective suit, but it wouldn't be able to protect you from everything. As you approached the storm, you'd realize that you made a big mistake in your mission prep. Your plan was to build your space station at the same altitude as the International Space Station, 400 kilometers into Jupiter's atmosphere. Yeah, except this storm is as deep as 40 Mariana Trenches. So it would swallow you up before you could finish your project. But now it's too late. You'd be plummeting through the storm and you'd get your first real glimpse of how powerful it is. You'd be thrown around at wind speeds of about 400 kilometers per hour. To give you a sense of how insanely powerful that would be, hurricanes are ranked into 5 categories based on strength. A Category 1 storm has wind speeds up to 153 kilometers per hour, strong enough to snap large trees. In the middle, a Category 3 hurricane can hit 208 kilometers per hour. These storms could result in devastating damage, including pulling roofs right off of houses. Lastly, a Category 5 hurricane back on Earth has wind speeds of 252 kilometers per hour or higher. That packs enough of a punch to collapse buildings, but that's still only half as strong as the winds in the Great Red Spot. Thankfully, your body can withstand wind gusts as high as 800 kilometers per hour, but that doesn't mean it would be refreshing in any way. Without the protective face gear, your skin would look as if it was melting straight off of your face. So make sure to hold on to that helmet tight. Not that you'd be able to do much else besides staying on a violent downward trajectory at this point. As you were falling into Jupiter, you'd see how clouds around you would change. First, you'd get a real close-up view of those ammonia and ammonium sulfide clouds you were mesmerized by before. Then you'd pass through clouds made of water, just like the ones on Earth. The temperature and pressure all around you would be changing too. Sadly, none of this would be comfortable for you, especially not at the same time. Where the atmospheric pressure is similar to that of sea level back on Earth, it would be a very chilly minus 110 degrees Celsius. And where the temperature was bearable, the pressure would be 8 times greater than what it was back on Earth. Now, the chances of surviving up to this point would be slim. I mean, look no further than the fate suffered by the Galileo probe. As it descended further and further into Jupiter, it encountered extremely high temperatures. And what do you think happens to a probe in that environment? Yeah, it vaporizes. Without a spacesuit strong enough to withstand all that heat and pressure, you'd end up disintegrating, just like the probe. Now you'll be one with the gas giant forever. Imagine you had to experience an apocalypse every day. Volcanic eruptions, tsunamis, asteroid showers. Every day would be a struggle for survival. That's because Earth is now a moon of Jupiter. Why are we being hit by so many asteroids? Could we survive in underground bunkers? And how much damage would Jupiter's gravity cause? This is What If, and here's what would happen if Earth orbited Jupiter. Now that we've joined Jupiter's 79 other moons, let's scope out our new neighborhood. Jupiter is the largest planet in our solar system. It's so big that it could hold over 1,300 Earths inside it. Yeah, for perspective, think of the Earth as a grape. Compared to us, Jupiter would be the size of a basketball. It would be a heck of a view, though. Jupiter would take up an enormous chunk of the sky. But once you're done stargazing, you'd notice how cold it's gotten. That's because Jupiter is 778 million kilometers away from the Sun. The nice, warm Sun. That means 25 times less luminosity and 25 times less heat than we have right now. And that's only a small taste of what's changed. 1 year on Earth is the length of 1 month on Jupiter, since it takes Jupiter 12 years to go around the Sun. If we were to compare Earth to Jupiter's closest moon, Io, your days would be about 40 hours long. But the good news is it'll give you lots of time to prepare. Look alive, you've got some work to do. If you want to survive out here, you'd need to go underground. You and all of humanity would set up shop in subterranean bunkers. Now, don't be expecting a 5-star bed and breakfast, all right? You'll be surrounded by thick, tightly sealed concrete walls so no gas, water, or radiation can get through. And before you get nice and settled, you'll need to ensure your bunker has a reliable power source, a sound air filtration system, and ample food and water supply. If you really feel like a hermit, you could convince your vault survival crew to build hydroponic farms. These farms use nutrient-rich water and artificial light to grow plants instead of the usual soil and sunlight combo. And speaking of sunlight, you're gonna miss it. A lot. Because you're now living underground, you'll be lacking in the vitamin D department. A workaround might be introducing some fish into your survival diet. Using aquaponics, fish and plants can be farmed together, even indoors. And eating fish will provide you with that sweet, essential vitamin D your body is craving. I know, it sounds like a lot of work, but trust me, it's worth it. You wouldn't want to live on the surface. That's because topside, there's a daily apocalypse. The gravitational pull from Jupiter's other nearby moons, not to mention the planet itself, would generate extreme tidal forces. The whole world would be falling apart. Literally. Monday, you'd have to deal with an earthquake. Tuesday, it's volcanic eruptions. Wednesdays, you've got tsunamis. And by the weekend, you've got the worst of all, asteroid impacts. Every month, Jupiter is hit by anywhere from 12 to 60 comets or asteroids. Now, the good news is Jupiter will take the lion's share of the bombardment, but the bad news is the ones that hit us could still do some serious damage. Jupiter's gravitational pull makes asteroids move faster. It's basically an asteroid with a nitrous speed boost, reaching a collision speed of about 216,000 kilometers per hour. And that's just the minimum. If Earth became one of Jupiter's moons, we'd be directly in the line of fire. One event like this occurred in 1994 when the Shoemaker-Levy 9 comet collided with Jupiter. If we took the hit instead of Jupiter, the 2-kilometer-long comet would strike us like a shotgun blast. Seriously, because of Jupiter's gravity, the comet would break up into 20 pieces, and the collisions from these fragments would be like getting hit by 300 million atomic bombs. Plumes of debris would shoot as high as 3,000 kilometers, and that's not all. These hits would cause our atmosphere to reach scorching temperatures of around 40,000 degrees Celsius. You know why they called it the Shoemaker? Because it just kicked our planet's ass! But let's say Jupiter took one for the team and the asteroids missed us. Well, you're not out of the woods yet. As you peeked your head out of the bunker to look at the surface, you'd realize your Geiger counter is going crazy. The weather today? Highly irradiated. If you lingered too long and got hit with 200 rads, you'd experience radiation sickness. You could look forward to vomiting, fatigue, and diarrhea, but still, you'd survive. Once you go past 200 rads, however, things would go from bad to worse. And for the record, rad is radiation absorbed dose. It puts a number on how much energy your body absorbed from radiation. And even as little as 2 rads can cause chromosomal damage. Except Jupiter's magnetic field is 10 times stronger than Earth's, meaning that it emits 1,000,000 times more radiation. At 400 rads, you'd really start to hurt. Your chances of dying would reach 50%, and you could feel your intestines and marrow falling apart. At 600 rads, you'd be dead. So you might want to go back inside the bunker, but before you do, take in that view one last time. You'd be able to see some of Jupiter's other moons, like Callisto, Ganymede, and Io. If you looked closely enough, you could even witness Io's volcanoes erupting. Even cooler, the aurora would be a full-time light show thanks to Jupiter's radiation. Beautiful, isn't it? Oh, okay, back in the bunker, pack it up. I don't feel so good. The biggest planet in the solar system has gone rogue. And now it's heading straight toward Earth. You have 30 days till this gas giant wipes us all out. What speeds would Jupiter be traveling at? What kind of havoc would it wreak along the way? And is there any way we could survive getting eaten by a planetary Pac-Man? This is What If, and here's what would happen if Jupiter collided with Earth. In our night sky, Jupiter appears a lot like a bright star. From our earthly point of view, only Venus and the Moon are brighter. But something strange is going on 588 million kilometers away. Jupiter has ramped up its speed to 225 kilometers per second. That's 15 times faster than its usual orbital velocity. So now, this gas giant, 11 times larger and 317 times heavier than Earth, is on the loose. And it's going to speed right at us until it's filled up the entire night sky. But don't worry, you could already be dead long before those 30 days are up. As it moved toward Earth, Jupiter would first pass through the asteroid belt. This region between Jupiter and Mars consists of hundreds of thousands of rocky bodies, ranging from tiny dust particles to asteroids almost 1,000 kilometers in width. But none of these would do anything to slow down the gas giant. The average distance between these asteroids is about equal to 7 Jupiters in a row, so there's a chance the planet could pass through completely unscathed. And in our night sky, Jupiter would now look double its usual size. Which doesn't seem like a whole lot to make everyone panic, but that doesn't mean it wouldn't cause a little bit of chaos on its trip. You see, Jupiter is vital to our solar system and to life on Earth. It acts as a gatekeeper to our cozy planetary neighborhood, protecting us from being bombarded with giant, life-ending asteroids all the time. Why? Well, because Jupiter's gravitational pull is massive, about 4 times stronger than Earth's. This strong pull redirects asteroids that could be on a collision course with us. And this is good news for you because even one asteroid as small as 5 kilometers across could end life on Earth as you know it. Just like what happened to the dinosaurs around 66 million years ago. But if Jupiter suddenly started heading toward the center of the solar system, it could send many dangerous space rocks our way. If one of them smashed into Earth, you might not live long enough to see Jupiter swallow Earth. But for the sake of our hypothetical scenario, let's keep you alive. For now. While sending asteroids on a collision course with Earth, Jupiter could also pick up a new moon or two. The asteroid belt is home to the only dwarf planet in the inner solar system, Ceres. It has about 25% of the total mass of the entire belt. Maybe this dwarf planet would join the 79 other moons that make up Jupiter's very faint ring system. Next stop would be Mars, and now Jupiter would appear almost 4 times larger than usual from Earth. Now, while the red planet could be lucky enough to avoid being obliterated by a head-on impact with Jupiter, it might not make it out untouched. Maybe the newly added moon, Ceres, would slam into it. And this wouldn't be Mars's first rodeo either. About 700 million years after the formation of our solar system, a huge asteroid even larger than Ceres collided with Mars. That collision tore away part of the Martian hemisphere, and the debris from that asteroid started orbiting the red planet, eventually forming its two moons, Phobos and Deimos. These moons still orbit Mars today. Now, at 16 million kilometers away, Jupiter would be closing in on the home stretch. From Earth, you'd see it bright and clear, as large as the moon. And from this point on, you'd start to feel some of the effects of Jupiter's powerful magnetic field. This field is the largest object in the solar system, and it's 18,000 times more powerful than Earth's. It would be so strong that it could trap charged particles and accelerate them. These particles would damage electronics in our passing spacecraft, and they could potentially penetrate Earth's atmosphere and magnetic field. And that would be really bad news. Now, you were lucky to avoid one of these planet-killing asteroid collisions, but now you and everyone else on planet Earth would start to suffer from severe radiation sickness. First, you'd be incapacitated by nausea, diarrhea, and vomiting. You'd also feel anxiety, confusion, and could lose consciousness. After a few torturous hours, you'd start to feel okay. But then, the final stage would kick in. You'd experience tremors and convulsions before ending up in a coma, or worse. If somehow you survived this, the ultimate end would draw nearer and nearer. Now, only 2 million kilometers away, the Great Red Spot would be the same size as the Moon, and the planet itself would appear 8 times larger than that rock above us. Earth would now be caught in a violent game of tug-of-war between Jupiter and the Sun. This could cause tidal heating all around our planet. Earth could become a hellhole, riddled with earthquakes and volcanic eruptions that would spew sulfur dioxide gases into space. All the while, Jupiter would be making its final approach. Now, as close as the Moon, it would occupy 40 times more space in our night sky. And as it crashes into Earth, the atmospheres of both planets would compress. This would rapidly increase the temperature, causing everything on Earth, including the air itself, to burst into flames. And in this colossal inferno, Earth would burn up in Jupiter's atmosphere until we fuse with the gas giant forever. I guess you could call us pretty unlucky to be the only planet swallowed up by Jupiter. The Sun isn't the biggest thing in our solar system, and it's not Jupiter either. But close, it's Jupiter's very own magnetic field. What would it be like if Earth's magnetic field was as huge as Jupiter's? How much stronger would our magnetosphere become? Why would it make solar radiation worse? This is What If, and here's what would happen if Earth had Jupiter's magnetic field. Earth is surrounded by electrically charged particles affected by our planet's magnetic field. This is called the magnetosphere, and it plays an invisible but very important role in keeping our planet livable. Without it, we'd be left unprotected from the sun's radiation. Plus, our atmosphere would leak out into the great beyond. So give a big thanks to our magnetosphere that extends as far as 65,000 kilometers into space. Our magnetic field is generated by a dynamo effect inside the Earth's core. That's when liquid metals in the outer core create electric currents, and then the Earth's rotation on its axis causes these currents to act like a magnet. If this magnetic field is so great for us, let's turn up the dial and make it thousands of times stronger. Fingers crossed it won't attract meteorites that would level your city in minutes. If you could see Jupiter's magnetic field from Earth, it would appear nearly 3 times the size of our moon. And that's huge, considering that Jupiter is a whopping 778 million kilometers away from us. When you got close to this behemoth of the solar system, you'd see it extending 3 million kilometers from Jupiter toward the Sun, and over 1 billion kilometers in the other direction, all the way to Saturn. If Earth suddenly had a magnetic field this huge, it would easily swallow up the Moon, and it would extend out past Mars, the main asteroid belt, and into Jupiter's orbit. But there's a catch. The size of a planet's magnetic field depends on how strong that field is and the strength of the solar winds it comes in contact with. These solar winds are the reason that the side of Jupiter's magnetic field facing the Sun is more compressed, while the other extends much further. Like Earth, Jupiter's magnetic field is generated in its core by liquid metals. Enormous amounts of pressure turn liquid hydrogen into a metallic form. Only Jupiter's core is much larger, significantly hotter, and rotates even faster. So for Earth to have a stronger magnetic field, our core would have to speed up and get hotter. Much, much hotter. And if we somehow made our planetary core rotate faster than Jupiter's, our magnetic field would become 18,000 times more powerful than it is today. But does stronger always equal better? One of the bigger issues you'd have to confront with this new, bigger, stronger magnetosphere is that it would no longer be so good at protecting the planet from dangerous charged particles from the Sun. That's because it would now behave a lot like a particle accelerator. This would be extra concerning if you had space travel planned anytime soon. All because the trapped solar particles bombard satellites, the ISS, and the Moon with large amounts of radiation. And nothing would stop them from passing through the ship's exterior. This would damage all your electronics, unless they were stored inside a 1.5 centimeter thick titanium vault. And if you were unlucky enough to be bombarded by these charged particles on a spacewalk, you could get radiation sickness and increase your chances of getting cancer. This could also cripple your nervous system, so you definitely don't want to find yourself floating in space surrounded by a magnetic field with that much kick. Down on Earth, the aurora borealis, or northern lights, would get an upgraded look. These form when the electrically charged particles collide with oxygen and nitrogen atoms. Now you would see the display pulsing. Oh, and they'd be dangerous too. That's because they'd be emitting X-rays, and that radiation could get funneled right down to the ground. This could lead to our poles becoming completely uninhabitable. Now, how might giving Earth a magnetic field from a planet 1,300 times its size impact you directly? Well, try living with a core moving so fast you'd be dealing with a dramatic increase in earthquake and volcanic activity. And let's not forget animals like bees, sharks, and even mud snails that rely on Earth's magnetosphere to keep them pointed in the right direction. They'd all be thrown off course with potentially disastrous effects on global ecosystems. The biggest planet in the solar system, and the smallest star in the known universe. Today, they're on a collision course, and Earth might not survive this. Meet the star with a catchy name, EBLM J0555-57AB. Its gravity is 300 times that of Earth's, and it's about the size of our Saturn. EBLM J0555-57AB is a red dwarf and the smallest star we've ever discovered. Usually, it resides 600 light-years away from us in its own double-star system. But not today. Today, it broke the cosmic speed limit and rushed toward our solar system to meet with the biggest gas giant in it, Jupiter. Let me just tell you, Jupiter is huge. It's about 11 times larger than Earth. It's even bigger than the red dwarf star coming its way, but because it's mostly made of hydrogen, it's not massive enough to be a star. To start converting all its hydrogen into helium and turn into a red dwarf, Jupiter would need to be at least 80 times more massive than it is today. So, what would happen if these two gas giants collided? Well, before the interstellar red dwarf could even make it to Jupiter, it would have to pass through the Oort cloud. The Oort cloud is a collection of icy comets and other bodies on the edge of our solar system. As the smallest star in the known universe was passing through this icy debris, it would wreak big havoc in our planetary neighborhood. Yeah, it would send icy comets our way, and some of them would start hitting Earth. We'd have to think of a way to protect our planet from this comet shower. But time would not be on our side, because the smallest star in the universe would keep moving toward Jupiter. Our stellar guest might be smaller in size than Jupiter, but it sure would be more massive. EBLM J0555-57AB's gravitational pull would start to tug on the planet. And don't forget that we'd now have a second star in our solar system. Things would start getting hot. All the heat from the red dwarf plus its strong gravity would make Jupiter grow in size. The gas giant's atmosphere would puff up as all the gases were heating up and expanding. Some of Jupiter's atmosphere would start to escape into space and toward the stellar intruder. Eventually, all the runaway Jupiter gases would form a hot ring around EBLM J0555-57AB. It would look as if we had a black hole in the solar system, only it would be really bright. The red dwarf star would keep slowly ripping Jupiter apart. Now, it would be eating whole chunks of our gas giant. For a moment, Jupiter would take the shape of an American football, but soon enough, the star would engulf it entirely. Sorry, Jupiter, you didn't stand a chance. But now we'd be in a real pickle. Jupiter would no longer exist in the solar system, and now we'd have an alien red dwarf star surrounded by a ring of hot gases. Our solar system wouldn't be the same without Jupiter. This gas giant wasn't here for a cool view. Jupiter's gravity usually attracts asteroids and comets that make it into our planetary neighborhood. It gobbles them up before they make it further into the solar system. With no Jupiter to protect us from all the space rocks, Earth would be getting bombarded by all kinds of debris. Icy comets, asteroids, you name it. Every day we'd be hit by about 170 meteors, comets, and asteroids. That's 10 times more than what's making it to our planet right now. Life here would sure get more dangerous. who knows how long before one really big asteroid would come and destroy all life on our planet. But things would get even worse. Having another star in our solar system would disrupt the orbits of all the planets it passed, including Earth's. Of course, it would take EBLMJO 555-57AB millions of years to rampage all the way to our sun, so you might stay alive long enough to witness the epic slow-motion chaos. Unless the red dwarf sent another planet on a collision course with us. Yeah, that would end things much, much quicker. All the planetary collisions in the solar system would create a rippling effect. The planetary orbits would get disrupted even more as time passed. Earth could even get knocked out of its orbit entirely. This would send you and everything else on the planet on a rogue trip across the universe. And without the sun to give us warmth, the Earth would turn into a frigid, lifeless rock very soon. If you somehow survived up to this point, you wouldn't have very long now.
Ever feel like the Earth is just too small? Well, let's make it bigger. Much, much bigger. Welcome to a new Earth that is just as big as Jupiter. In what ways would Earth change? What things would stay the same? And how would this affect you? This is What If, and here's what would happen if Earth were the size of Jupiter. A super-Earth is a planet with a mass up to 10 times bigger than the Earth. But don't let the name deceive you. These super-Earths aren't anything like the Earth you know. These planets could be rocky or covered entirely in ice. They could even be gaseous like Neptune. But if you want to make the Earth as big as Jupiter, get ready to make a super, super, super Earth. While Earth, as it exists now, is much smaller than Jupiter, it is a pretty dense rock compared to the gas giant. Our new planet would be massive, about 1,300 times bigger than Earth today. And that's not the only thing that would be different. Jupiter has a radius about 11 times that of Earth. Get used to a little more gravity when you walk around. Yeah, 11 times more. So, if Earth was this huge, how soon would the gravity completely crush your body? This change in size would have enormous implications for you and all other life on Earth. The first thing you'd notice with 11 times the surface gravity is that you would weigh more. And there's not much a diet plan could do to change that. You'd be 11 times heavier than you are now. So, if you currently weigh 70 kilograms, well, get ready to start lugging a hefty 770 kilograms around. Would you even be strong enough to carry your own weight? Well, you'd be heavier than the world deadlifting record of 501 kilograms held by Game of Thrones star Hafthor Bjornsson. So, yeah, good luck. But if you were a couch potato, this could be good news. Getting up from the couch wouldn't be an option. You wouldn't have the muscle strength. Even breathing would be a near impossible task. Scientists have concluded that the maximum gravitational field that humans could adapt to is about 5 times the gravity of Earth. Well, now double that, and that would be your new normal. And you wouldn't be the only one feeling heavier. All that gravity would result in increased atmospheric pressure. Yeah, you'd feel the air pressing down on you. This would have severe environmental impacts. water molecules would need more energy to escape their liquid form. That means the boiling temperature of water would be much higher than 100 degrees. And the freezing point would now be way below 0 degrees. It would be harder for you to make ice. And even the large chunks of ice, like icebergs, could melt away. And there would be disruptions beyond life on the surface of Earth. Introducing a massive planet into the solar system would create some serious instabilities. Our moon would experience extreme changes in tidal forces. This gravity could be strong enough to pull the moon apart into teeny tiny pieces. The only remnant you'd have left would be a new ring of debris forming around Earth. The sun would still be 250 times more massive than our new Earth, so Earth wouldn't steal any planets away, but our super-Earth could have some effect on their orbit, just as Venus and Jupiter impact our orbit and climate today. The Earth would affect the orbits of other celestial bodies like asteroids. Our gravitational pull could be strong enough to eject these objects from the asteroid belt and set them on a collision path with you. And that would be bad news. Remember, you wouldn't be able to move a muscle to escape. So maybe it's better if Earth stays the same size as it is now. What if Jupiter's 79 moons weren't gravitationally bound to Jupiter? What if they became rogue objects, orbiting on their own paths around the sun? Would they still be moons or something completely different? Could one or more collide with Earth? And which moons could host extraterrestrial life? This is What If, and here's what would happen if Jupiter's moons scattered across the solar system. Jupiter is the largest planet in our solar system. It has a surface gravity 2.5 times the Earth. And the planet's gravitational pull, combined with its great distance from the Sun, are two of the reasons why Jupiter has so many moons. These moons range in size from the smallest, S2010J2, to the largest, Ganymede. It's larger than the planet Mercury. Another of Jupiter's moons, Europa, is about the size of our own moon. And both Europa and Ganymede could have oceans of liquid water frozen beneath an icy surface. So, if Europa and all the other moons abandoned their orbits, what would they become? Well, how about hot, hellish rocks on a deadly collision course with the Earth? While there's no exact definition of a moon, experts say that it's an object that orbits a planet or dwarf planet. So, the moment Jupiter's moons leave their orbits, they would stop being moons and become something else. If the larger moons like Ganymede, Callisto, or Europa gravitated toward the Sun, they could end up in the habitable zone of our solar system. This is the range within 0.9 to 1.2 astronomical units of our Sun. That's where the Earth is residing. Here, conditions are possible for liquid water to exist. And possibly life, too. So, if any of these moons settled into stable orbits within this so-called Goldilocks zone, you could catch the first glimpses of extraterrestrial life in our solar system. Just give it a billion years. But if these moons continued on their rogue orbital paths, they would likely end up being too cold or too hot to have conditions to support life. The ice that covers these moons would reflect sunlight into space. That means the rogue moons would have a high albedo. This would create a vicious cooling cycle as the sunlight would reflect instead of heating the icy surface of the moons. So that means instead of the ice melting, more ice would form, which would lead to more cooling and more ice, and so on. On the other hand, there could be an equally unstable warming cycle. Water vapor is a greenhouse gas that traps heat in the atmosphere, just as carbon dioxide does on Earth. The hotter the planet, the more water would evaporate. That would lead to more water vapor and more heat. But more on that in a minute. Jupiter's former moons would require 10 to 40% more sunlight than the Earth in order to not become icy snow globes wandering the solar system. Plus the help of other greenhouse gases like carbon dioxide and maybe some volcanic eruptions. But too much help and that rapid warming effect could kick in, leaving the former moons hot and uninhabitable. Then what? Well, now you'd better start to worry. These 79 rogue objects could end up on a collision course with us. At 2 kilometers wide, the smallest moon, S2010J2, would cause damage wherever it collided, but if any of the larger moons hit the Earth, you'd be doomed. Scientists say that if an object with a width of 96 kilometers collided with us, it would wipe out all life on Earth. And, sorry to say, Jupiter has many moons that meet this deadly criterion. Your only hope would be that our planet could potentially catch one or more of the moons in our gravitational pull. But that hope would be short-lived, because life on our planet would become difficult. Or impossible. Yeah, higher tides would render the coastal regions uninhabitable. You'd experience massive and more frequent tsunamis, earthquakes, and volcanic eruptions. And these eruptions would spew out dust and toxic gases that would block out sunlight. But on the bright side, you'd now have 2 or more beautiful moons in the night sky to admire. Uh-oh! Looks like somebody left the gas running on Jupiter. Don't do anything stupid like lighting a humongous match. What would a match need to be made of to ignite this gas giant? How big would it have to be? And how much damage would this explosion do to our solar system? This is What If, and here's what would happen if you lit a match on Jupiter. Okay, you've heard me say this before. Jupiter is the largest planet in our solar system. It's 300 times more massive than Earth, but it's less dense than our home. With no solid surface, this planet is almost entirely gaseous. It has an atmosphere composed of 90% hydrogen, about 10% helium, and trace amounts of methane and ammonia. With so much hydrogen present, pretty much all of Jupiter must be flammable, right? So, if you lit a match, how much of that wooden stick would burn off before it all goes kaboom? Okay, before you go ahead and strike that match, there's one big catch you didn't account for. Fire needs oxygen. Without any oxygen in Jupiter's atmosphere, it would be impossible for the planet to erupt in flames. Not only that, but lighting your match would be difficult, to say the least. Usually, when you drag a matchstick across the red strip on your matchbox, you start a series of small chemical reactions that end in a flame. When you apply friction to the box, red phosphorus converts to white phosphorus. This mixes with the oxygen in the air and ignites. Without oxygen, this ignition wouldn't happen. But since you're so determined to set Jupiter on fire, you'd have to find a way around this obstacle. For starters, you'd need to reinvent the matchbox. You'd need one that could ignite the match without the need for external oxygen in the atmosphere. So you could lose the white phosphorus in your match. Instead, you'd need a match that could generate enough heat from friction to break down potassium chloride on the matchstick into oxygen. The flame would keep burning as long as the matchstick coating lasted. But one matchstick wouldn't provide you with the oxygen you'd need to ignite Jupiter. You'd need a lot more. Again, considering that Jupiter is the most massive planet in our solar system, you'd be burning off an astounding amount of hydrogen. To be precise, about 1.4 multiplied by 10 to the power of 27 kilograms of the stuff. For hydrogen to combust, you'd need about half as much oxygen present in the atmosphere as there is hydrogen. As you might have guessed, you'd need to gather a lot of oxygen. And because molecules of oxygen are way heavier than molecules of hydrogen, the total mass of oxygen we'd need would be about 6 times the mass of Jupiter. Yeah, there isn't enough oxygen in the entire solar system for this to happen. Sorry to disappoint you, but Jupiter won't be erupting in flames anytime soon. And before you try to get creative with your methods, let me tell you that even the most energetic impact that ever occurred on the gas giant didn't cause a single spark. In 1994, the comet Shoemaker-Levy 9 crashed into Jupiter. As it entered the atmosphere, it broke into multiple pieces. Some were as large as 1 kilometer in diameter. The total impact of all these pieces was massive. So massive that the total kinetic energy was many times more powerful than the Hiroshima nuclear bomb. But still, no flames. The 2 biggest planets in our solar system in one telescope view. Catastrophe is imminent. If Jupiter and Saturn suddenly were on a collision course, which of the 2 planets would emerge victorious? How would the composition of these planets affect the outcome? And what impact would this have on the rest of our solar system? This is What If, and here's what would happen if Jupiter and Saturn collided. On December 21st, 2020, Jupiter and Saturn were closer than they've been in nearly 400 years. This legendary event has an epic name: the Great Conjunction. You could see both planets in the same telescope view. They appeared as a single star in the evening sky, but they were still pretty far from an astronomical collision. If the 2 gas giants came a little closer, it wouldn't be the first time Jupiter has gone head-to-head with another planet, and you can probably guess who won that battle. Both Jupiter and Saturn are almost entirely gaseous, primarily consisting of hydrogen and helium. And while they may have solid cores, there's no sharp transition between the layers. Jupiter would have some significant advantages. It's about 3 times as massive as Saturn, with almost double the volume. And it's moving faster too. Jupiter's rotation speed reaches 13 kilometers per second, while Saturn rotates at just below 10 kilometers per second. But Saturn brings a wild card to the fight. Within its 2 rings, there are at least 150 moons and moonlets. If the planets drew closer together, Jupiter's strong gravitational pull would cause these moons, moonlets, rocks, dust, and ice to accelerate toward it. Some of them would be torn apart. That's what happened when the comet Shoemaker-Levy 9 collided with Jupiter in 1994. Originally, the comet was nearly 2 kilometers wide. But by the time it crashed, Jupiter's gravity had torn it to pieces. And those fragments smashed into Jupiter with the force of 300 million atomic bombs. Yeah, and that heated Jupiter's atmospheric temperature to nearly 40,000 degrees Celsius. Titan, Saturn's largest moon, is over 2,000 times larger than that comet, so the force of it alone colliding with Jupiter would be massive. If Jupiter and Saturn collided, they would begin to merge. Their atmospheres would mix. That would raise the temperatures in the top layers of the gas giant's atmospheres. It would get so hot that Jupiter would experience a chemical reaction, gaining more iron, silicates, and even water. Eventually, Jupiter would absorb Saturn, or most of it. Scientists at Sun Yat-sen University in China modeled a scenario about what happened when a massive planetary embryo, about 10 times the size of Earth, collided with Jupiter 4.5 billion years ago. The impact was so energetic that it destroyed Jupiter's original compact core. This formed a more diluted core composed of a dense mix of liquid metallic hydrogen and helium. But if Jupiter collided with Saturn, that event would be 10 times more massive. Large amounts of material would spread out in space, and then all that material would come together into a single planetary object. We'd call it New Jupiter or Jupiternus. And maybe that new planet would cause more trouble in the solar system than you might expect. Jupiter is sometimes referred to as a failed star. That's because its size and composition are similar to a brown dwarf. But Jupiternus would be more massive and have higher internal pressure. If the temperature was high enough, this could cause nuclear fusion in its core. Yeah, Jupiternus could become a star. And the impact of having 2 stars in our planetary neighborhood would be huge. It could even mean the end of life on Earth. Now, don't worry, if these 2 planets merged, Jupiternus would have a mass 30% greater than Jupiter, but for nuclear fusion to ignite, the planet would need to reach a mass of 75 Jupiters. So life on Earth would go on, but this would be a spectacular show with tons of gas and debris expelled. Maybe it would all be illuminated by the sun, giving us a beautiful, glittering end to Saturn as we know it. As our biggest planet, Jupiter's immense presence helps to hold our solar system together. Its massive size and gravitational pull give it a dense atmosphere, a turbulent mix of hydrogen and helium. This results in unfathomable storms that have lasted for centuries. But let's imagine Jupiter came in closer contact with an even bigger object, the Sun. Would the Sun strip Jupiter of its atmosphere? And if so, what would that look like? What makes Jupiter such a unique gas giant? What is Jupiter's core made of? And what are hot Jupiters and hot Neptunes? This is What If, and here's what would happen if Jupiter lost its atmosphere. Jupiter's gravity is nearly 2.5 times stronger than Earth's, making it difficult for any atmosphere to escape. Thankfully, it also keeps out incoming asteroids. Jupiter has dense layers of gas consisting of 90% hydrogen, 10% helium, and a few traces of ammonia, sulfur, methane, and water vapor. It has an extended dilute core made up of rocky material, ice, hydrogen, and helium. And unlike Earth, there's no sharp transition between Jupiter's core and its outer atmosphere. Scientists believe the core could have been formed from a head-on collision about 4.5 billion years ago between Jupiter and a planetary embryo 10 times more massive than Earth. A recent discovery of the exoplanet LTT 9779b by NASA's Transiting Exoplanet Survey Satellite, or TESS, may unlock even more answers to Jupiter's formation and possible destruction. NASA's discovery of the Jupiter-like exoplanet LTT 9779b has captivated the scientific community with its miraculously close orbit to its star. While Jupiter maintains a safe distance from the Sun, LTT 9779b is so close to its star that its atmosphere is evaporating at an accelerating pace. What makes it so unique is that close orbits are usually reserved for Earth-like or Jupiter-like planets, but LTT 9779b is somewhere in between, closer in scale to Neptune. With an ultra-hot temperature of about 1725 degrees, astronomers have unimaginatively named it Hot Neptune. Oh yeah, clever guys. Personally, I would have gone with the Blue Inferno. Astronomers believe that the exoplanet may have formed further away from its star and has slowly made its way closer and closer over millions of years. The closer it gets to its star, more and more of its atmosphere evaporates, giving it a squished, almost football-like appearance. American football. LTT 977b is losing its atmosphere because it has surpassed the critical distance where a planet begins to lose mass due to the tidal forces caused by another celestial body. This is known as the Roche limit. Luckily, Jupiter is far enough away from the Sun to maintain its mass. And its moons are far enough away from Jupiter not to be absorbed. So, why do most gas giants, like Jupiter, reside so far away from the Sun? Well, all planets were built in the same way. The Sun's gravity pulled dust and rock together, while the Sun burned off gases such as hydrogen and helium in the inner solar system. The outer parts stayed cool. This provided just the right temperature and materials for planets to form atmospheres. Some astronomers have suggested that there are Earth-like planets out there that may have once been gas giants. For unknown reasons, they have entered the Roche limit and lost all their atmosphere, becoming hot Earths. There are even hot Jupiters out there, like the exoplanet 51 Peg, which is similar in scale and orbits its star every 4 days. For Jupiter to start losing its atmosphere, it would need to come closer to the Sun and surpass its Roche limit. While this isn't likely to happen, if Jupiter got nudged toward the Sun, it would slowly start to spiral closer and closer to it. It would lose more mass with each orbit. Eventually, it would get so close that it would orbit the Sun in a single day, 88 times faster than Mercury's orbit. The Sun's strong solar winds would give Jupiter a tail of gas like a comet. This enormous amount of gas could cloud the light of many stars, making our night sky much less impressive. During this slow process, Jupiter would be squished and eventually lose its atmosphere. It would be left looking like a barren, rocky planet, like Mercury, but about the size of 11 Earths. As we continue to explore and discover more exoplanets like hot Jupiters or hot Neptunes, scientists can better understand planet formation, which is vital to our understanding of the universe. In 5 billion years, we're going to have a hefty problem on our hands. Well, only if we're still living on Earth at this point. Our sun will be on the brink of collapse. If we don't find a way to give it all the fuel it needs, well, we're toast. How could Jupiter help us refuel the sun? What other stars have consumed gas giants? And what would life be like without Jupiter? This is What If, and here's what would happen if we refueled the sun with Jupiter. The sun's delicate balance of hydrogen and helium keeps us alive and well. Although you might think there's an infinite ball of energy up there, I hate to break it to you, but the sun's not sticking around forever. In order to keep it going, our sun needs a consistent source of hydrogen. At its core, the sun's hydrogen is converted to helium in the process of nuclear fusion. This fusion reaction is exothermic, meaning it gives off more energy than it consumes. This energy is released as gamma radiation, which provides enough of an outward push of gravity to keep the sun from imploding. So, how exactly can Jupiter help with all this? Well, about 90% of Jupiter's atmosphere is made of hydrogen. This makes it one big ball of fuel, even though it's only 0.01% the mass of the sun. Astronomers have located a sun similar to ours that has been eating a Jupiter-like gas giant called WASP-12b. Good one, science. I hate wasps too. WASP-12b's atmosphere is being sucked up by its star, forming a hot ring of gas around it. As its atmosphere is pulled outward, this is making the planet puff up to 6 times the size of Jupiter. Our sun gobbles up hydrogen at a rate of 620 million metric tons per second. With 4 gas giants in our solar system, we could keep the sun sizzling for another 87 million years. With Jupiter being the biggest, we'd probably want to start there. In order to pull this off, we'd need to set up Jupiter like WASP-12b, close enough to the sun to deliver a constant influx of hydrogen from its atmosphere. It would have to be just enough hydrogen so that no mass is added or lost from the sun. In other words, like a healthy diet and exercise with an occasional cheat day. But couldn't we just smash Jupiter into the sun? That sounds like more fun to me. Well, this would make for some good fireworks, but this would increase the sun's mass too quickly, causing it to burn hot enough to turn global warming into global roasting. The key is to keep the sun's mass stable so its fusion remains consistent at its core. Even if we managed to nudge Jupiter close enough to the sun, that could lead to a whole slew of other problems. Because without Jupiter's stable gravitational pull, all of our planetary orbits, including Earth's, would be thrown off course. And we'd lose our precious shield against deadly asteroids and comets. So, realistically, we'd probably have to suck it up and move somewhere else. Who knows? Maybe there's a really nice Earth-like exoplanet out there for us to settle.
How do you feel about a little game of solar system trivia today?
Solar system trivia? Well, why not?
Sweeping the nation.
I mean, if there's one thing I probably know a bit about is the solar system. Working at What If, half of our videos are set in space, so I could probably keep up.
You think you know your way around the solar system, do you?
I mean, yeah, enough. I can get there.
Okay, let's get cosmic. Start the insanity. Where is Earth in relation or proximity to the sun in the sort of order of planets? Where is it?
Well, this is Solar System 101. And actually, sorry, it wouldn't really be Solar System 101. I say that only because during the 2000s, it kept getting rammed in my head. This NBC promo, Thursdays, watch.
I think it was must-see TV.
Third Rock from the Sun.
John Lithgow, Jane Curtin, Kristen Johnson, and of course, a young JGL,
who I think is a great actor.
Joseph Gordon-Levitt for the non-converts.
Right. We were just saying earlier, I really like that guy. I think he would be friends with us for some reason.
I would hope that he's a fan of the show. So yes, JGL, if you are listening.
JGL. Call us JGL.
Yes, we'd love to have you on. Okay, question number 2. What is the smallest planet today in our solar system?
Today. Well, I know where you're trying to lead me down in that pathway, but here's a little tidbit that maybe you do know, maybe you don't know. Ceres. A lot of people don't know Ceres. It's a dwarf planet, which would technically make it the smallest planet in the solar system, although it's not technically a planet. It's the largest body in the main asteroid field in between Mars and Jupiter.
Yet to be upgraded to planetary status.
Yet to be upgraded. So in that case, I would say Pluto, except for the fact that this is where you were trying to suck me in. Mm-hmm. Pluto was downgraded in 2006.
Bad day for Pluto.
Lost planet status, although there's still a lot of people around the world who are fighting for Pluto.
Yes.
Still, the smallest planet then becomes Mercury. And for bonus points, I'm going to tell you Mercury, just slightly larger than our moon.
Well, for showing off, you'll be deducted points. How is that? Next time, just answer the question.
Protest.
Finally, what is the largest planet in our solar system?
I think every schoolboy knows that's Jupiter.
And that is correct. And of course, most people do know that Jupiter is the biggest planet in the solar system, but not much more than that. So what if Jupiter never existed?
Well, I can tell you, I do know a lot about that. Normally, I wouldn't know a lot about something like that, but I did provide the voice for the What If video, What If Jupiter Never Existed. I can tell you a few things about it, but it'd probably be smarter for us to have a special guest that might be able to expound upon that.
Like maybe an astronomer from NASA?
Why not? Dr. Steve Levin received his PhD in physics from Berkeley in 1987. He began his career at NASA's Jet Propulsion Laboratory in 1990. He's the project scientist for NASA's Juno mission. Juno is a solar-powered spacecraft which has been orbiting Jupiter since July 4th, 2016. For a few hours every 53 days, Juno passes within a few thousand kilometers of the giant planet and collects a wealth of new information about Jupiter. The data collected so far has revolutionized our understanding of Jupiter and of giant planets in general.
Great to have you with us, Dr. Levin. Thanks for joining us here today on What If Discussed.
My pleasure. Sounds like it's going to be fun.
Well, we're going to be talking Jupiter, and
that's fun.
We'll get to the bigger what if in a bit. But to be honest, Peter and I were talking sort of before you came on that, most people know that, Jupiter's the biggest planet in the solar system.
11 times the size of Earth.
11 times the size of Earth. I think most people don't know that, but a good factoid. Mm-hmm. Some people might know that it's a gas giant. I didn't know for years that it was the 5th planet from the sun and that we're separated, Mars and then Jupiter, that close to Earth. But I mean, basically my point is relatively little common knowledge about Jupiter. It didn't feel like we'd been able to do much exploration. Well, the Juno mission that obviously you're such a big part of has changed the game. How much have we learned about Jupiter since Juno sort of left Earth in 2016?
So the phrase we like to use around the project is it's a whole new Jupiter. Basically, we sent Juno to Jupiter to measure a bunch of things that hadn't been measured before, to try to peek beneath the clouds, right? Because even though Jupiter, as you said, is 11 times bigger than the Earth, that's the radius. So it means you could fit over 1,000 Earths inside it. It's the most massive planet in the solar system by far, more than twice the mass of all the others combined. And we've been studying it for hundreds of years. Galileo looked at it with his telescope hundreds of years ago. Even though we have all of that, mostly we didn't know what lay beneath the clouds. We'd look at Jupiter from the Earth, and it's this giant atmosphere and it's covered with clouds. So we sent Juno there to use gravity to measure what the interior looks like, to measure the magnetic field which comes from deep inside the planet, to use radio waves that can see through the clouds, to go over the poles of Jupiter for the first time, really, and take great pictures in the north and south where you can't see it from Earth because it's all in the same plane in the solar system. A whole bunch of new kinds of measurements, measuring particles in Jupiter's magnetic field, things like that. And essentially, everything we measured gave us a surprise. We were looking for, is there a dense core down in the center? And sure, we expected something between maybe 3 and 20 times the mass of the Earth down in the center. But what we found looks like maybe it's not a dense core with a sharp boundary. Maybe it's sort of fuzzy and it takes up like half the radius of the planet. We measured the magnetic field and it was way more complex than we expected it to be, with all these bumps and wiggles in it, and it doesn't look like a dipole like the Earth's field. And it's way different in the north than the south. We measured through the clouds with our radio receivers, and we found that the deep atmosphere doesn't get well mixed the way you'd expect. Everybody thought, get beneath the clouds, and it's this giant ball of gas. It should be pretty much the same anywhere you look. Well, that's totally wrong. So we got surprises every single thing we took a look at. Even the pictures over the North and South poles, it looks so different that the first time we looked at the pictures, a lot of the people in the room were saying, "Are you sure that's Jupiter?" It just didn't look at all like Jupiter looks like from the side.
And those pictures have been shared, right? And where can people find those pictures, just before I forget?
Yeah, so there's this great opportunity out there. So we have a website called Mission Juno, missionjuno.swri.edu, but you can get to it from NASA's website or just Google Mission Juno. And the JunoCam images, that's the images from our visible light camera. Basically, we just dump the raw data out on the web and let anybody who wants to play with it, make their own pictures, fix up the colors, stitch things together, however much work you want to do, and post them. And we've gotten an amazing response. There's several people out there who are real power users who take that data and turn it into these amazing pictures beginning to end. There's a lot more people who take the intermediate steps and use those and try stretching the color, changing the contrast, or combining them to make movies and do some great things. People are doing science, people are doing art, people are making pretty pictures. It's really been fun.
Talk about that planet in relation to our planet. I don't know if everybody knows how much Jupiter may have affected Earth's development. Among other things, it's protected us from a lot of flying rocks, but what else? Right.
So the flying rocks thing is basically, if you imagine something drifting into the inner solar system, when it gets near Jupiter's orbit, Jupiter gravitationally is likely to perturb it, and a lot more of those get shot outward than get shot inward, so it can protect us. But we're generally just the formation of the whole solar system. When we look at how did planets form, which, by the way, is something scientists don't really understand all the details about, the most important models for how does the solar system form, how do we get the planets, indicate that Jupiter came first, not too surprising because it's the largest. It got there first, it got all the material, and then it affected the formation of the whole rest of the solar system. So there's lots of ways to think about that, but the one I like the best is if you just look at our solar system like you were an alien or something and don't know what's there, you'd come along, you'd see the sun, and you'd say, maybe that's it, that's all there is this star. And you'd be 99.5% right or something, because almost all the mass is in the sun. And then if you looked a little bit further and said, oh, wait, I see that speck, that's Jupiter, right? You'd be more than 2/3 right if you said that's all that's left, because Jupiter's more than 2/3 of the remaining mass. Well, the sun formed first, and then Jupiter formed out of the leftovers from the sun, and then everything else formed out of the leftovers from Jupiter. So in a really important sense, if I want to understand where did the Earth come from, I better start with where did Jupiter come from? Otherwise, I'm never going to get the picture.
So I guess the short answer to what if Jupiter never existed would be Earth wouldn't have existed, and I'm guessing the rest of the solar system wouldn't have existed?
Well, I love that question because it's actually way more complicated than it sounds. So imagine, when you asked me that question, the first thing I thought of is, okay, imagine Jupiter just didn't start to form. What would happen? Well, the answer there is probably one of the other planets would have gotten a whole lot bigger and sort of become like Jupiter. Because if you look at the other really big ones, it's Saturn and Uranus and Neptune, what we think most likely happened is as the planets formed, they drifted around because they're eating up the material that makes the initial cloud of gas and dust, and that changes their momentum, and so their orbits shift around. And those other planets probably came along after Jupiter was really big. Jupiter altered their orbits dramatically. Looks like it probably sent them outward away from the sun. And they didn't have as much stuff. Jupiter ate all the stuff first before they could get there. So if Jupiter wasn't there, well, maybe Saturn drifts in further and Saturn eats all the stuff and looks a whole lot like Jupiter does now. Of course, exactly where they ended up depends on all of that process. So if you take Jupiter out of the mix, you totally rearrange things. Maybe we get a giant planet close to the sun, or maybe we don't get a giant planet anywhere near the sun, and there's really big ones out far away, and we only have little planets close to the sun, or have 6 of them or 10 of them instead of 8 or 9. All of that would be different if Jupiter didn't form. And on top of that, well, if you say, okay, suppose Jupiter formed and we got all the planets in the right place, but now I'm going to just reach in and pop Jupiter out of the picture and say, what happens? Then you get a totally different kind of answer, right? The other planets don't get perturbed that much anymore, but anything that's falling into the inner solar system, like comets and asteroids, mostly really small rocks, maybe you wouldn't call them asteroids, meteors, things like that, without Jupiter there, they don't get perturbed the same way. Their orbits are very different. Mars isn't big enough to do much of anything. So then you worry about, well, we get hit by comets more often, or if you pluck Jupiter out of the picture after everything formed, but before everything had settled down, then you get a different answer. Maybe the amount of water on the Earth might be different because Jupiter probably influenced that. So any step along in the process, if you don't have Jupiter, you get a different picture. But what picture you get depends on when you took Jupiter away.
It's funny because these days, you know, more people are talking about how interconnected things are here, how we have to be reminded that even though there's seemingly a lot of distance between us and the other side of the world, and in fact, everything has this sort of butterfly effect, if you will, and affects everything else. So it's interesting to see that that's the case. Obviously, the further we zoom out into the solar system as well. You mentioned smaller rocks, and these days, of course, the moons around Jupiter, I think, especially in this sort of astronomical circles, are getting as much attention, maybe even as Jupiter, especially Europa, Ganymede, etc. What has Juno been able to sort of glean more about Jupiter's moons?
Okay, so first I should say our most important job so far about Europa has been to stay the heck away from it. And that's because people are very excited about the fact that Europa appears to have a liquid water ocean underneath its icy surface, and maybe find life in that ocean. So picture 20, 30, 40, 50 years from now, you finally built a system that can do it, and you fly to Europa and you land on the ice and you dig down beneath the ice, and we don't know whether that's a few feet or a few hundred miles, but you dig through the ice, you get into the water, you sample the water, you find life, and then you have to say, but I don't know if that came from Europa or contamination from when Juno hit it 50 years ago. That would be a problem. So because we're there to study Jupiter, we have to be, and we didn't go through all the steps you do for, say, a Mars mission to make it as clean as possible and have no bacteria on it or anything like that, nothing that could survive. We have to show we're not going to contaminate Europa. And what we did at the beginning is we said, all right, well, we're there to study the main planet, not Europa. We'll just stay the heck away from it. However, we're coming near the end of our prime mission. We're writing, actually sending it in today, I think, an extended mission proposal to NASA to ask to keep giving us money to continue because the spacecraft's doing well and we have lots of great new science we can do. And part of that proposal, which of course NASA will have to decide if they have the money, part of that proposal is to study Europa, because we think with our radio receivers that we use to look at the atmosphere, we can look at Europa and tell you something about maybe how thick the ice is and whether there's water near the surface. We have other instruments that if we're lucky, maybe we'll see a plume and be able to tell something about whether Europa has geysers or not sticking out into space. We can look at all the other satellites, and I would not think of that as, assuming it gets funded, as a like prime mission that studies the satellites, because that's not what we were there for, and we're not geared to do everything you want to do to study Europa. But it's a great advanced scout mission for NASA's mission Europa Clipper or the European mission JUICE that want to go to Jupiter and study those moons and learn a lot more. We can learn a little bit that might help them refine where they do their measurements and what they do. We can measure some things that they weren't designed to measure because they're focused on stuff that was more Europa specific, and we have instruments that were really focused on Jupiter, so we measure slightly different things. There's lots of great stuff we can do if NASA decides that they want to fund our extended mission or has the money to fund the extended mission. And
wow.
if it includes Europa.
Some breaking news here on What If discussed.
Yeah. To say that this is the golden age of space exploration would be an understatement. We talked about the Juno mission. NASA launched a probe to Mars earlier this year. We got the announcement last week, and we had a guest on talking about the possibility of phosphine on Venus and what that might spur in terms of further exploration. What is it like to be working at NASA these days?
I got to say, it's really fun. I mean, I've been working for NASA one way or the other for about 30 years. And it's always been fun because we're exploring. We're trying to figure out things where nobody knows the answer. But right now, we're getting close to some really important answers. We're learning, it's in my lifetime, in my career as a scientist, is, at the beginning of my career, nobody had discovered any planets around any other star besides our own. Now it's practically routine. Oh, they found another planet around some other star. And it's only interesting if it's a special case, if it's more Earth-like or it's really close to its star or really far from its star or things like that. We're getting distributions of that. We're learning how many planets there are typically in our own solar system. We're learning about different ways to look for life within our own solar system, and we're getting further along doing it. Our robots have gotten so good that we can launch robotic spacecraft and do these exploration things that, when I was growing up, I thought only, you'd have to have people there to do. And of course, it's way easier to send a robot than it is to send a person, mostly because the robot doesn't care if you give it a ride home. So all of that, it's really a great time to be doing space exploration.
Yeah, and I mean, with the way the world is these days, I know Peter and I have experienced this before, that when we get to talk to people like yourself that, help us zoom out and remind us that the world isn't our little navel-gazing day-to-day, that there's just obviously so much beyond this planet, so much to look forward to, and even so much to be optimistic about the future versus all the dystopian sci-fi and post-apocalyptic stuff. I think we see a lot. It's easy to forget that. So this is great. Can you stick around and talk? You mentioned some of those exoplanets and kind of future NASA missions. Can you stick around for a bit?
Sure.
So we are going to take a break with Dr. Levin right now, and he will be part of the extended audio podcast. Exactly. Which you can find, I guess, if you're watching YouTube, the link is where, Peter?
Listen, if you're watching this on YouTube right now, you want to click on the link and you'll get the extended audio version of the podcast, and we can hear the rest of the conversation with Dr. Levin. But if that's all the time you have for us today, then well, that's fine too. You're going to stick around because we're still going to do a little video chat after this, and then we'll check in on part 2 later. But
Peter and I will sort of sum up our takeaways from the first half. Where can people, you mentioned the website for the footage from the Juno mission. Where can people find that again? And where can people follow your work?
So the easiest thing for people to remember is if you go to NASA's website and search for Juno, you'll find all of this stuff with links to everything. But the main Juno website is a site called Mission Juno. So it's missionjuno.swri.edu. And if you just Google Mission Juno, you'll find it. Or if you do a web search for JunoCam, you'll find us. It's pretty easy. Just so long as you got NASA or Jupiter or something in there to keep from getting confused with all the other Junos out there.
Like the Juno Awards up here in Canada.
Google will get you there, basically.
Which honor the best of Canadian music. You don't want, that's an entirely different Juno.
You might want to see that.
Yes, Dr. Levin will...
Do you want that site too? It's pretty interesting.
I think Alanis Morissette won a Juno back in the day as Alanis, but that's a story for another what if. Okay, Dr. Levin, sit tight. We'll be back with you in a sec. And Peter and I will be back to sort of sum up our takeaways from our conversation with Dr. Levin about the Juno mission and what if Jupiter never existed.
Cool.
So I guess like Dr. Levin and the people at the Jet Propulsion Laboratory with NASA, they learned stuff. We learned stuff. They learned that some of the things that they had assumed or known about Jupiter turned out not to be true or were at least more than they had expected, of course, because they got to finally actually look at it from a
quality pictures,
digging
deeper. So they got to go beneath the gas surface and see what's happening down there.
Had some assumptions about it, but in fact were, I think, happily proven wrong.
I like when NASA does some things like that and we find out about it and we can bring it to the viewers. It's almost that fast.
Well, in this particular case, you're having some real-time learning going on because, again, he's giving us the sort of the backstory as to what they learned at the time, and then we're learning that. And to your point, then people listening or watching are learning. I learned also that we have this sort of big brother, big sister relationship with Jupiter on Earth, right? It's been essentially shielding us, protecting us for all this time. And I had never, honestly, before, I know it sounds stupid maybe, but I'd never thought that, all that space debris and asteroids coming in this direction would have naturally potentially hit us if we weren't kind of protected from that side.
You know what I thought was interesting was that if Jupiter, he gave us an idea of how the universe was formed. Jupiter obviously was, or not obviously, we learned today, or I learned today, it was the second object in the solar system. And if it hadn't been there, or if it wasn't there, there's a possibility Earth wouldn't be here either.
Yeah, so it's not a small relationship we have with Jupiter, and what if Jupiter never existed? As it turns out, again, as we sort of put it out there, if Jupiter never existed, there's the possibility that Earth never existed, but he also added a bit of a sort of a caveat to that whoever else would have been there, they might have gotten, let's say, the leftover mass.
Yeah.
So maybe in a different scenario, Earth would have been the size of Jupiter, and instead of having 7 billion people here, we'd have 700 billion people here.
Or maybe it wouldn't have stayed in the habitable zone, or maybe it would have gotten too big and there wouldn't have been enough water on it to sustain life. There would have been a whole host of other reasons why maybe life didn't exist, never came to be on Earth.
You know what it sounds like to me, Peter?
Sounds like a story for another what if. Well, if you want to hear more of our conversation with NASA's Steve Levin and you're watching the video podcast on YouTube, well, what you're going to do is click on the link below and it will take you to the extended audio version. Now, some of you are listening already on the audio podcast. There's no link for you. Don't look for anything.
Just stay tuned.
No. So join us on the other side. We'll talk more about life on other planets and
space exploration and a whole bunch of other cool stuff.
Europa.
The Earth has been hurtling towards Jupiter for the past 242 days. And now it's about to make impact. Now we're so close to the giant planet that it's the only thing that fills our sky. Ground temperatures on Earth are rising uncontrollably. Our atmosphere is igniting into flames, and the scientific community is scrambling to provide answers.
what will happen when the two planets collide? Is there any chance that we could pass right through the gas planet? And how would this collision transform Jupiter forever? This is What If? And here's what would happen if Jupiter swallowed Earth. One way that scientists could find answers would be by looking into the past, because this wouldn't be the first time that Jupiter has collided with another planet. Nearly 4.5 billion years ago, Jupiter was involved in a violent collision with a planet 10 times the mass of the Earth. In that case, the collision completely transformed Jupiter's core, but what happened to the other planet? And what can that tell us about our own planet's chances of surviving a crash into the gas giant? To get some answers, let's travel back to 4.5 billion years ago, when Jupiter was just a young planet trying to find its place in the universe. Back then, Jupiter's gravitational pull became 30 times more powerful in just a fraction of a million years. This destabilized the orbits of nearby infant planets and caused some of them to crash into Jupiter. It's believed that one such planet was 10 times the mass of Earth, and it was mainly a silicate ice core. The planet hit Jupiter with an impact speed of 46 kilometers per second. Jupiter only lost a small amount of mass from the collision, but its original core was completely changed. Before the impact, Jupiter had a dense central core of heavy elements, and the rest of the planet was made up of hydrogen and helium. After the impact, the infant planet's silicate ice core merged with Jupiter's, causing Jupiter's core to become diluted. The heavy elements spread out and mixed with the outer layers of Jupiter. While this collision was a defining moment for Jupiter, it meant the end of the road for the other planet. So, what are the odds that the Earth's fate would be any different? Well, let's find out. The Earth orbits around the Sun at an average velocity of 29.78 kilometers per second. At this speed, if the Earth were to just leave its orbit around the Sun and head straight for Jupiter, it would take about 242 days to get there. Throughout our journey, Jupiter would shine like a bright star, growing bigger day by day, hour by hour. By day 6, Jupiter would appear as bright as our moon. Soon, we would start to notice our daylight becoming dimmer. We'll only get about 50% of our normal sunlight when we reach Mars's orbit. Luckily for us, the Earth's atmosphere would act as a buffer, so we wouldn't experience the cold right away, but that will only last a while, so you'll need to invest in some heavy-duty winter gear. To put it in perspective, Mars has a surface temperature of minus 63 degrees. So that's basically what we'd have to look forward to. Once we speed through Mars's orbit, we'll pass through the asteroid belt. We'll get to see beautiful meteor showers lighting up the sky, but we'll also be at risk with colliding with some of those meteors, so let's keep moving. After 242 days of traveling through our solar system, we would finally reach our destination, Jupiter. As the Earth is pulled into Jupiter, our planet's velocity could increase until it reaches 60 kilometers per second. That's 250 times faster than an airplane flies, so you'll want to hold on tight. Oh, and did we mention that Jupiter has 79 confirmed moons orbiting it at all times? So there's a serious risk that we could collide with any of them as the Earth is pulled in closer. And if we do happen to avoid all those moons, things would only get worse. As we crash into Jupiter, both planets' atmospheres will be compressed, rapidly increasing the temperature and essentially setting the air on fire. But at least we won't have to worry about colliding with Jupiter's core, because we'll never make it there. Our planet is too small and would burn up in the atmosphere before that ever happens. But this would have a huge impact on Jupiter, as the Earth's remains would completely mix into its atmosphere. So if you ever notice our planet going off course and heading towards Jupiter, you might want to jump off along the way. Maybe right as we pass over Mars. The observable universe has a diameter of about 92 billion light years. Within it are planets, nebulas, asteroids, the list goes on. But what would happen if we got rid of a single planet? Specifically, our largest planet, Jupiter. How important is this gas giant to our solar system? How would it affect life on Earth? And how would this change Earth's development? This is What If, and here's what would happen if Jupiter never existed. If Jupiter was no longer in our solar system, having one less planet to aspire to travel to would be the last thing we'd have to worry about. This gas giant ranges from 600 to 1,000 million kilometers away from Earth. But despite it being so far away from us, we'd experience direct implications right here on Earth. Why is this? Well, to say that we'd notice Jupiter's absence here on Earth is a bit of an understatement. This is due to Earth not being around, at least not in the current state as we know it today. Sure, it would still be some sort of planet, but it's very unlikely that there would be any complex life forms. No fish, animals, and certainly no humans. Earth has been hit by tons of asteroids and other space rocks. According to some experts, they may have brought water and other essential substances down to Earth. But although some asteroids can be good, there's plenty of bad ones. Some would be big enough to wipe out entire civilizations, just like what happened to the dinosaurs 65 million years ago. This is where Jupiter's role comes in. Although it has slipped up a couple of times throughout the history of our solar system, Jupiter has been protecting us. As millions of asteroids have been heading towards Earth, Jupiter's gravitational pull has grabbed the asteroids. This puts them in Jupiter's orbit and unable to reach Earth. Without our giant protector, Earth would be hit by a lot more asteroids. And it's unlikely that another planet would step in to fill Jupiter's place, considering that the gas giant is the only planet big enough to attract all these asteroids. This means Earth would get hit by thousands more asteroids than it ever has before. Some would be small and could maybe help Earth, bringing us new elements. But it's possible Earth would get hit by a couple of big ones. Enough to destroy anything that would be evolving on the planet, and maybe enough to destroy Earth itself. So, we know we probably wouldn't be here if Jupiter had never existed, but what if it suddenly disappeared today? Our solar system would have developed in the exact same way, but Jupiter suddenly blinked out of existence. For more on how our solar system as a whole would shift and get all out of sorts, you can check out our episode, What If Earth Was the Only Planet in Our Solar System? But if only Jupiter disappeared, it might be a good thing. Despite being our protector, occasionally Jupiter messes up and might miss a couple of things. Jupiter threw a comet towards us 350 years ago. Luckily it missed us, but it wouldn't have been anywhere near Earth in the first place if it wasn't for Jupiter. What if Jupiter gained just a little bit more mass during its formation period and then ignited to become a star? How different would our solar system have turned out? Would having another star in the middle of the solar system mess with the orbits of the planets? And would we see it from here? This is What If. And here's what would happen if Jupiter became a star. Jupiter has more than twice the mass of all the planets in the solar system combined. It doesn't have a solid ground and is made up of the same elements as the Sun, and yet it's not a star. Jupiter doesn't have enough mass to initiate a fusion reaction in its core, the necessary requirement to be accepted into the star club. If only we could find 79 more Jupiters and crash them all into the one we have now, we'd be able to build a second star in the solar system. What would that be like? 80 Jupiters crushed together would make a star out of the gas giant, but that star would be nothing like the Sun. Jupiter would be massive enough to become a red dwarf, a small, cool, hydrogen-burning star. And, as every red dwarf out there, it wouldn't be too bright. 0.3% of the Sun's luminosity is the most light that Jupiter could hope to spit out. Because Jupiter is 4 times further away from us than the Sun, the Earth wouldn't get much heat from it. By and large, Jupiter turning into a red dwarf wouldn't change anything for life on Earth. You'd still be able to see it from Earth. A Jupiter star would appear red and a bit brighter than the Moon at its full phase. Would it at least have a gravitational impact on the solar system? Not as much as you might think. The former gas giant would slightly shift the orbits of the other planets, but not enough to set them on a collision course with one another, or to launch them out of their orbits into outer space. The only threat we'd face would be space rocks from the asteroid belt that Jupiter might send towards the Earth. We'd need to learn how to detect and destroy them before they could reach our planet. Other than that, not much would change for the solar system. Things would get a lot more fun if Jupiter was replaced with a Sun-like star. If our gas giant became 1,000 times more massive, the solar system would go wild. Asteroids would crash into planets, and planets would change their orbital course. It's hard to predict what would happen to Earth in this gravitational mess. It could be anything from being pulled a little too close to Jupiter's star and getting scorched, to being left drifting alone in the void of space. In any case, it wouldn't be too pretty. In the real world, Jupiter is forever destined to be a planet, and that's for the best. Maybe someday soon we'll get a closer look and send a manned spacecraft rushing inside the gas giant. But that's a story for another What If.
Jupiter may be the biggest planet in the solar